Why do you require me to measure the weight of the gas without a container? Is it some kind of gotcha or something?
Yeah, because you can't weigh the atmosphere. It proves that there's no pressure.
Why do we have to weigh the atmosphere?
Show that there's gravity, to show there's pressure.
I mean,
why can't I just weigh a part of the atmosphere?
My next question for this guy would be: do you think you can have gas pressure without the container?
Sure.
You can?
Gas pressure doesn't require a container.
Oh, all right.
Because in their world, Jeremy,
you can try and argue that gas pressure and atmospheric pressure are two different things, but they're not really. They're both gases, and they're both got a pressure.
Are you a flat earther?
No, I'm not. The cause of the pressure is different mechanisms, but there's still pressure there.
I agree with you. Gas pressure. It's gas pressure. I agree.
So you agree that the cause doesn't matter?
This guy is good. I like this Glover. He's good.
Oh yeah.
Except for the fact that he thinks you have gas pressure.
He still thinks gravity is a thing, though.
I'm a bit stumped about how the pressure at the bottom of a helium balloon is the most dense, because even though helium balloons go. Let me finish, mate. So when that helium balloon goes up to the atmosphere, and when a helium balloon goes up to fucking space, basically, or nearby, if it's dense at the most dense at the bottom, when it even gets them sort of heights, like you can clearly see that the tension of that balloon is an upward. So I'd assume there's more pressure at the top of the helium balloon than would be at the bottom.
Rummy, we spent hours just. Oh, sorry. Go ahead.
Yeah, no, because you're conflating what's on the outside of the balloon with what's on the inside. If you've got pure helium on the inside of the balloon, it will create a gradient with the densest part of that helium at the bottom of the balloon than the top. That doesn't mean that the balloon won't rise, because when you're talking about the balloon rising, you've got to then think about the medium that's around the balloon, not just what's inside the balloon.
I just want to state that yesterday, Jake's argument that helium in the tank was pressing mostly down, which was giving it its weight. Otherwise, it wouldn't have any weight. But now in the balloon, you're saying it's still pressing mostly down?
Yes.
No,
yes.
It looks
Wouldn't
like
that make it go down?
Up. Maybe the weight's at the top of the balloon.
That's what I was willing to test. Jeremy's afraid to chime in.
It's not the weight of the helium inside the balloon that makes it go up. It's the pressure external to the balloon. The pressure differential between the bottom of the balloon and the top of the balloon. There's more pressure at the bottom of the balloon than there is at the top of the balloon, and so it goes up.
That makes sense. I think the other thing I want to bring attention to is that like water, for example. Let's say we fill the balloon up with water. Because there's more water at the top, because there's more water on top of the water at the bottom of the balloon, you would have more pressure at the bottom because it's contained, right? So it would that would also give you a gradient, because you got more. Let's imagine a ball pit, and that's what water is. So
why do we have to keep imagining stuff?
Because that's what you do.
That's all right.
We all agree.
Stuff all the time, though.
So let him get his analogy out.
Point out. So when you've got, if we say like you're inside, you go deep diving into water, into the ocean. You've got more ocean on top of you, pulling down on you. So I know you guys think it's gravity pulling it down, but let's say without gravity, you've still got more molecules on top of you crushing you. So it's pretty much that's why you have more pressure at the bottom than you would at the top.
Yeah, that's right. But it's the bit that you say more water pressing down on you. It's that pressing down on you bit that you seem to want to deny, right? That pressing down on you, that's called weight, and it's gravity that gives the water that weight.
Ooh.
Yeah, I mean, I just use that assuming gravity.
I'm not assuming it.
I think it still works without gravity, to be honest.
How?
Well, just by relative density.
Gravity doesn't even come into the equation. It's not a thing we can manipulate.
No, relative density doesn't explain why the water pushes down.
Heavy things go down, lighter things go up.
All right. Now, this comes back to the question of why in a tube with helium. Now, this has yet to be proven to you, but I assure you it's true. There will be a homogeneous mixture of just helium. There will be a density gradient at the bottom, with the densest being at the bottom.
Well, we've just established that because obviously
So
when
how
you
does
put more,
density and buoyancy do that?
well, as we just established that the more stuff you have on top of something, with more molecules on top resting on each other, creating
What made the
a
helium go
pressure
down?
downwards. What makes the helium go down?
Yeah.
It's just there's more of that medium above it than there is below it.
Why'd
Temperature
it
would
go
make helium
down?
go down.
Do all helium molecules have the same mass?
Yeah, they change
yeah,
depending
they
on
do.
temperature, right?
Do all helium molecules have the same mass?
Yeah, they do. They do, yeah.
Good. Do they have the same volume?
Yeah, I'll assume so.
Then they
It's
have
really-
the same. Then they all have the same density. So why would some helium molecules prefer to be at the bottom than others that would prefer to be at the top?
It's just like
If relative density is your explanation,
no, that's my
all
question
these
then, Tor.
all these helium molecules have the same density.
Oh, you asked me a question and then you started talking. So if I've got one orange on my head and then I put 2 oranges on my head and 3 oranges on my head, there's three times of oranges weight on top of my head.
It's because of gravity.
Well,
Yeah,
first
you
you have to
keep
prove.
subscribing. You subscribe to gravity, but it literally doesn't really need it, does it?
Hold on.
It
First, they'd
does.
have to prove. Hold on a second. First, they'd have to prove that there is more helium molecules at the bottom.
You're not
can't
willing
just
to
say
test
that. It's a-
You're not willing to put your money where your mouth is, Jeremy.
Yeah,
So-
that's
This
right.
isn't
That's
my
exactly
claim.
right. They
You
have to
guys are
prove that.
claiming. You guys are claiming there's more helium molecules at the bottom. Show it, or you're making a
I'm
baseless
willing to show it,
assertion.
but you have to
You're
take the
boychick,
risk
I was
because I
talking.
know the answer. It's a waste of money. So
You're
if,
making a
if I'm going
baseless
to take the
assertion.
risk,
Is what this is
I-
called.
I-
I'm
Put the money up.
perplexed. Sorry, I'm perplexed because I didn't ask to be subscribed to helium or gravity. How much is this costing me to have that subscription?
no, this is.
It was forced
this
on
is-
you when you
rises
were a
up
kid.
anyway, regardless of what
You know
what's
what I'm
happening
saying,
in the
Chemo?
balloon. It all rises up.
Of course, Jeremy.
No, Jeremy, this
fuck the
is
pressure
between
gradient.
you and me. Are you willing to put?
It's
You're
not. It's,
confident of your
it's disproving
decision.
gravity.
Can I
Gravity
pull?
doesn't
Can I
exist
pull you
because
back
of
to
that
my
helium
question?
balloon.
Can
That's
I
what it
go
is,
back to?
period.
Can I go back to my question? I
Your
want an
question is-
explanation. I want to know an explanation for why the density is greater at the bottom when all the molecules apparently have the same density.
I just explained it. It's like a ball pit. All the ball pits are all the same density and same volume, same diameter. And if you're under a bath of loads of them, it's gonna be more pressure at the bottom of having all them balls on top of you than it would be at the top.
Yes, we have gravity.
But you
well, I know
haven't.
you- I know
You
you
haven't
guys-
given an explanation for why.
Reasons. Are you
You're
trying
just
to
saying- You're just saying it has to be
Are you like
gravity.
denying
I
gravity?
think-
Is that what's
No,
going on?
I'm saying it works without gravity. That's what I'm saying. It's not denying it.
How?
I'm
You're
saying
not
it works.
explaining how it works without gravity.
You're not explaining it. You can't explain how it works with gravity. You can't
Yes,
explain
I can.
gravity.
Yes, I
All right,
can.
please give me an explanation
It
of
works
the,
with gravity
Einstein's-
because the
Hold on,
molecules have
hold on.
weight.
Explain to me general relativity.
That's
Don't need
not
to.
what we were on about. We weren't talking about.
Well,
general
that's what gravity
relativity.
is, right? Gravity is general relativity.
No, gravity is
It's
the
an
force
effect.
of down.
It's an effect. No, well, yeah, but it's all come from general relativity. Special relativity is a large blanket of
Irrelevant.
space-time, right? Hold on. Special relativity is a large blanket of space-time.
No, it's not.
General relativity. Yes, it is. Yes, it is.
No, it's not.
Yes, it is. Yes, it is.
No, it is not.
Yeah. All right, then, but
You're
you
straw
give me your
manning
explanation.
the argument.
No, we're not. No, I'm not. I'm giving you this. I'm giving you the example of special relativity, which is a blanket of space-time. Yeah.
No, it's not.
And then when you let me finish anyway. I don't really give a fuck because I know I'm right. General
You're
relativity.
not.
General relativity is
Brabby.
when you put a large
Oh,
body of mass
Brabby.
on top of that special relativity, that big blanket, right?
No,
You
you've
spend-
got it
You're
completely
wrong
wrong.
there and wrong.
Stop
You're
talking.
completely wrong.
If you want to talk about it, I'll give you the chance to talk about it. You kept quiet. Now I'm telling you about it. So shut your mouth. Let me finish my explanation. Then you can talk about it after. You can point out what's wrong
You're
about it.
wrong.
But whilst I'm in the middle of talking about it, please just
From the
just sit
start,
down,
you were
refrain
wrong.
from talking and telling me I'm wrong
Rest
when I'm
is
not.
irrelevant.
So let me finish. Right. So special relativity is a blanket of space-time. Now, when you put a large body of mass on that blanket, it then bends and warps the medium, which gives it an illusion of that celestial objects are going to be orbiting around that large body of mass. So it gives the effect of a gravitational pull. But the actual two masses aren't being attracted. It's just an illusion from the bending and warping of space-time. Now, there is a gravity well that happens under that large body of mass, and somehow that's been transformed into the body of mass of having an attraction to the center of that mass. So I would like you to explain that. So if I've got it wrong, that's fine. You now can correct me and explain it much better. Thank you.
For a start, special relativity has nothing to do with the curving of space-time. In special relativity, you did. You said it was
no,
the
never.
warping.
So it's a blanket of no one ever. Special relativity is a blanket of space-time. Then I went to general relativity when you put a large body of mass on that.
So you feel comfortable
so
interrupting me with my answer.
You don't fucking listen.
You demanded that I listen to your answer, and now when I try to give you my correction, you interrupt me and start talking over me.
That's not what I said.
All right?
Don't say what I never said.
Let me give my answer before you interrupt me.
You explain your version. Don't straw man mine.
So why did you complain when I interrupted you? Because you were wrong.
I think about it. You're now quoting me.
Why did you complain when you were wrong?
You think it is. Explain what you think it is. Don't tell me what I said because you got it wrong. Tell me what you think it is. Yes, you did. It's all recorded, bro. You can go listen to it.
Yes, I can.
You've got a fucking memory of a fucking glowfish. You are a glowfish. You've just remembered. I never said what you just said for a start. Secondly, I asked you to explain what you think it is. Don't try and correct, explain what misrepresent what I said.
You said space-time is a blanket, and Paul said it's got
never
nothing
said
to
that.
do with. Excuse me, you just said it twice.
Yeah, and I'm telling you that it's not a blanket. Special relativity is not a blanket of space-time.
Okay, that's what I did say.
And I was trying to tell you were wrong, and you fucking interrupted me like a mole.
You said it was. You said it was curved. You said special relativity is not curved.
Slow down and listen.
You're doing it again.
Slow down and listen to Paul, or I'll mute you so you can listen to him.
Yeah, God. Right, for a start, special relativity is not a blanket of space-time, all right? And as well as that, general relativity and special relativity are two entirely different things. In special relativity, space-time does not curve. Space-time is flat in special relativity.
That's what
when you talk, Jesus. So when you're talking about special relativity, it's got nothing to do with general relativity. Okay? Now,
when you put
Jesus.
Brahmy, this is your last fucking warning.
You are misrepresenting.
And in general relativity, yes, masses do make space-time warp. And the path that an object takes under gravity in space-time in general relativity is a geodesic. That's the curve, that's the path that the object takes. And it makes that path, and it takes that path as if it was being attracted, mass attracting mass. That doesn't mean that that's the explanation, but that's the path the object takes. Whether you like it or not, that's what happens.
Okay, well, I'd like to say that when I said special relativity is a blanket of space-time, that's what I said. And then you also said that it wasn't right accurate, but literally you've just repeated the same thing by saying it's a fabric. It's literally the fabric of space-time, like a blanket of space-time. The reason that special relativity is related to general relativity, because when I said you put a large body of mass on top of that special relativity, which is that blanket of space-time, it then bends and warps that time, making it general relativity. So yes, they are connected, and yes, I was right, and yes, what you just argued against something you just then agreed with. You just said it in a different context, which is the same thing.
No, that's not.
And I asked you to explain.
Can I respond now without interruption? You just strawmanned me again. I did not say that special relativity was a blanket of space-time. I'm specifically saying it's not a blanket of space-time. It's not two-dimensional. You don't put a mass on a blanket of special relativity. That's completely the wrong way to talk about it. Yes, there is such a thing as space-time, and in general relativity, space-time can warp. It's not synonymous with putting a ball on a blanket of something. That's not a very good analogy.
When did I say?
Not finished. That's not how it goes. And no, general relativity and special relativity are two different things. In special relativity, space-time does not warp. All right? You have time dilation and length contraction, but you don't put things on a blanket of special relativity. That's not a correct terminology. You did. That's what you said. Literally what you said.
Finish off. When did I say that space-time was to two-dimensional. When the fuck did I use the word two-dimensional?
You implied that when you said it was a blanket of
implied it.
space-time.
I implied two-dimensional when I said it's a
Yes,
a blanket.
you did. Yes,
I
you
implied
did.
it was two-dimensional. Right.
That's
not
what
my
saying
fault.
a blanket of space-time does imply, does it not?
So what blankets are two-dimensional, are they? A blanket's two-dimensional.
Are you really going to go
I've never
down
seen a
this
two-dimensional
argument?
blanket in my life.
For fuck's sake.
I've never seen a two-dimensional. What two-dimensional
You're a
blanket you
fuckhead,
talking about?
so Jesus Christ.
There are no
Who
two-dimensional
cares
blankets.
what you got to say, look? When the fuck did I?
I would
He's
like to
just.
add
I never said two-dimensional. He just took what I said and strawmanned it.
Just
No reason you're
When
correct again.
someone says
No,
blanket,
reason's really
you
on the ball
automatically assume
He means the analogy was that's irrelevant if it's not 2D. If you're going to say that space-time is a blanket, then you're describing a 2D surface in which you put these objects on.
No, I'm not. Well, how did they explain it in
blankets
fucking
aren't 2D,
classrooms?
bro.
They get you a blanket and they put a fucking large bowling ball in the middle of it.
Tell you
It's
that that's
fucking
not. They tell you
insane.
that that's not.
That is exactly the terminology people use.
I
What the
know,
fuck
no,
are you guys
it's
talking
actually
about?
not. It's actually not the
It
terminology.
actually is
They-
Kosho.
they-
I'm talking
Brummy,
Kosho.
listen, stop
Kosho,
talking,
you're
Brummy.
wrong.
Brummy,
You
stop
can't even
talking.
talk about this.
Brummy, you're
you
about to
are the
look like
worst
an
person to talk
asshole.
about special relativity.
Because yeah, Brummy, stop
You-
talking.
Oh yeah, I'm being an asshole because you're trying to white knight this guy.
Shut up!
here.
I realize that what you're saying is
You
stupid.
don't understand what the
I'll
fuck
tell
you're on
that
about,
wrong.
mate. You're a fucking idiot.
For fuck's sake, dude. Stop talking. Why does everyone have to tell you that? Listen, dude. When there's they do that trampoline demonstration, they specifically tell you this is not a depiction of what's happening. That no one teaches that that's what happens. They do that to show the kids and the students that this is an idea of what's happening, but it's not at all an explanation for what's happening whatsoever.
I never
The
fucking
reason
said it
that's
was a
2D.
two-dimensional fucking blanket.
Yeah,
Shut your
that's
fucking mouth.
describing a 2D.
Shut your mouth. Nobody fucking said it was a 2D blanket. That's what he took from what I said. That's not my fault. That's his fault. So you want to talk to somebody, talk to that fucking idiot because he's the one who took from what I said and twisted it. He strawmanned my example. I never said nothing to do with two-dimensionals. That's what he took from what I said.
Okay, now
Because
turn
he's a
this.
fucking idiot.
Says the
He's a
idiot-
fucking idiot. That's why.
There's the idiot who says a blanket of special relativity. Now that's an idiotic thing to say.
So go and look at some YouTube videos explaining special relativity, and when they say it's like the fabric of space time is like a blanket, right? That's what the special relativity. It's flat, and it's like it never says it's two-dimensional. So I don't know where the fuck you got that from. No, I'm not wrong. I'm not wrong. I'm quoting exactly what they teach. You lot just love to say wrong, but you're all wrong yourself.
These guys don't even understand their own model. They don't understand their
Don't
own
even
model. They
understand
think
it.
that
Exactly.
time space is two-dimensional. And the
Bremy,
Come
how many
on, man.
dimensions? Present for quiet. How many dimensions are in these videos that you're talking about, Bremy, in which they show this fabric? How many dimensions are in there that this object's moving around?
Well, no, the point being, right, this guy explained special relativity exactly the same as I explained it.
Right now,
He
Bremy.
explained special
Red
relativity
herring,
the same
Coco,
way I
come on.
explained it. Oh, you're wrong, but I'm going to also explain special relativity the same way. that you
Kosho,
did.
is the blanket supposed to be 2D?
Question is, shut
Are you
up.
saying it's
Shut up,
actually 2D?
Bennett.
No, answer the
Bennett,
question.
shut up.
It's not a
Shut up,
one-on-one question.
percentage.
Let him help Brummy out.
Yeah,
If
it's a question of Bremy, Chemo. So he's going to answer the question.
he doesn't have
And
to
the
answer
videos
the
that you just
question.
fucking couldn't stop talking over us to tell us about, how many dimensions are the blankets they show us?
No, fuck you.
Yeah, they're two dimensions, jackass.
Go fuck
All right, so
yourself.
your fucking foot.
They're
fuck
three-dimensional
yourself.
blankets.
No, they're not,
There's no two-dimensional blankets, bro.
Both of you guys, you're
The
jackass.
guy just said I was wrong and then explained special relativity exactly the same. He said I was wrong and then explained exactly the same thing.
How does that relate with things, objects dropping to the ground? Come on.
Kosho, you can't argue that the
Fucking
blanket should be
idiots.
2D.
Honestly.
When time-space, by definition, is three-dimensional space with a one-dimensional time.
Hold on. Let's say that again, percent. Hold on, guys. Can't hear everyone. Ben,
If
say that again.
space-time or time-space, by definition, is three-dimensional space
No shit.
with
Listen,
one-dimensional time.
Kosho, we can't even hear what you're
It's
saying.
Two dimensions.
It's not relevant because in the videos they're showing a 2D. That's the whole point. We know that it's 3D space. And
The other thing that's quite irrelevant here too is that I've been telling you all along that this warping of space-time has nothing to do with special relativity. This blanket demonstration, the blanket demonstration you're talking about, has nothing to do with special relativity.
Well, I'm trying to tell you,
That is not how they explain special relativity.
That's the fabric of space-time. It's nicely undisturbed.
Has
That's
nothing to do with science.
Exactly.
So basically, that special relativity is the normal state of the space-time. When you put a body of mass in it, it becomes general relativity. So it has something to do with it because it's space-time. You fucking idiot.
So you've studied this, have you, Brummy?
Yeah, I've got 10 degrees in it, man. 10 degrees.
What about a couple of PhDs, bachelors, all these things with it?
I've never said that I had, but he just
Mippet,
Brummy
it doesn't
seems to
matter.
make out that he's
Okay, these things
brilliant.
are for the public, for anyone to look at. Okay, and that's
Chemo.
Yeah.
Shut up.
what we're looking at is the cause to your effect, which is that is
Chemo.
science.
No, we weren't talking about you. Paul was asking you a question and you were avoiding it. So can we get back to that?
What's Paul's question?
Why is there a gradient when all of these molecules have the same density?
Temperature,
There isn't.
Paul,
You can't put
temperature.
chemo. This is their baseless assertion. Hold on. This is their baseless assertion. They're saying that there's a gradient inside a tank when it's all helium, right?
Yep. Are you willing to test that?
No, this is your claim. Why am I willing to test it? It's your claim.
I'm
You're
willing
willing
to test it, Jeremy.
Jeremy.
I pay for it if I'm right.
Come up with some proof for your claim, or just you can't make
Will
that
you
claim.
pay
Oh, in
for
the
it if I'm
helium,
right?
yeah, there'd be no gradient, right? It'd be all over the
can't-
place.
They have
Okay,
no.
well,
They're
you and
making
Chemo
this
pay
claim, but
for
they
it if
have
I'm
no
right.
proof, Chemo. They
Will
want
you
me to
pay-
pay. They want me to do the test
Jeremy?
to prove their claim.
No,
Jeremy, why
I
don't
want
you
to pay for it if
respond
I'm
to
right.
the person asking the question instead of getting Chemo's little, oh, yes, you're right. How about you answer the person that asked the question?
Will you pay for it if I'm right?
I'm not. Listen, I don't think it's fair that I should have to pay to
You don't.
back up
Only
your.
if I'm right.
I was
No,
right.
You don't,
no,
you
he's not
don't,
going to pay for
you
it.
don't have to pay for anything because I'm not talking about inside a tank now. I'm talking about just in the atmosphere. Do the nitrogen molecules at 20 kilometers up have the same density as the nitrogen molecules at sea level? Do they?
Sure, we got cycles going. This is a very dynamic system. We got
Do
going
they have
here.
the same density? I didn't say anything about cycles.
Same density. It's going to be a different temperature, Paul.
So what? Do they have the same density?
Who's
Yes,
snoring?
yes, they do. Yes, they do.
Somebody's
So if it's
snoring.
relative density that makes things go down, why are more of the nitrogen molecules down here?
Gee, no one's got an answer for you, Paul.
No,
What was the
of
question?
course I don't.
What was the question?
Because it's not relative density.
Yeah.
Could you repeat the question?
Go back and
Why?
listen to it on the record.
Why
because
is it? Why is it? Why is it denser down here?
Oh.
Why is the atmosphere denser near the bottom?
Because that's the way the gradient set up.
Why is it set up like that? How is it set up like
why
that?
we have a pressure gradient at the bottom. It's because the bending and warping of space-time. And you want to sit there and say that special relativity has nothing to do with general relativity. And I explained why it does. You never give me a response to that. So if you want to get your little smart mouth and give me an answer of why that when we talk about the special relativity, it's the fabric of space-time, it is absolutely essential to be with general relativity, because when you put a body of mass in that special relativity, it becomes general relativity. So would you like to explain that?
Why we weren't talking about any relative.
Well, we are still talking about what gives the
Reasons.
molecules weight at the bottom. This cunt here was speaking to me saying it's got nothing to do with it. What it fucking has.
He's gonna answer.
Hold on. Before he moves on to that,
Guys,
he
stop
asked
talking.
why is it
Yeah,
more
that's
dense
Brummy.
down
There was a-
here?
We're talking
Nobody
about
else should be talking
before you
about Paul.
came in there.
To the guy that was posing the question, he said that, why is it more dense down here? But he also said that there's two things that have equal density. What are those two things that you're talking about?
Nitrogen molecules. The nitrogen molecules at 20 kilometers and the nitrogen molecules at sea level. They both have the same density.
Yeah, but you do know that like nitrogen, it's a diatomic molecule, right? That's what they claim.
Sure.
So you could and as far as we know, we could have clusters of them, right?
Sure, but the molecules themselves have the same density.
Yeah, but if there's more of them, then the volume changes, so the density is changing.
But the volume of the actual molecules themselves doesn't change at all.
Of course not. But that's not what we're talking about. If they're clustered together, then you take it as a one object, basically, right?
No,
it's diatomic.
Because they are still individual molecules, and they roam around like individual molecules.
They're molecules in space, so the mass is the same for each individual molecule, but the volume is changing, thereby changing the density, as per the equation D equals m over v.
Boom.
But the density of each individual molecule is still the same, regardless of the density of them as a group. The individual molecules still have the same density.
That's absolutely irrelevant, though, because these molecules have space in between them, and that space is what's just like that's what's.
Why is there more space?
What's in that space between the molecules?
Is just space, so we don't know exactly, but that's what like volume is. Volume is the space that an object is taking. You know, so if these molecules are taking up less space, they're more expanded, they're more spread out.
That's just another way to
change the density.
The same question, though.
But they're not taking up. The molecules themselves are not taking up any more space. The molecules are taking up the same amount of space. What you're saying is that the space between the molecules is changing. My point is that the molecules themselves have the same density at high and low altitudes. Therefore, if it's relative density that makes things fall, then why are there more nitrogen molecules which have the same density as those nitrogen molecules up there? Why are there more of them down here?
We have different temperatures.
I'm telling you,
there's a dynamic
they're contained,
system.
right? They're together. So you can't just like pigeonhole it and talk about the individual molecules because they're together. Just like if you have a balloon where the gas is expanding, it's still, it's going to act as one object.
Percentage. We have a dynamic system. We have different temperatures when you get higher. I mean, there's a lot of things going on. This isn't just as simple as
Jeremy.
So each tennis ball in a group of tennis balls is different to a single tennis ball on its own. Is that what you're getting at?
Can we kind of bring it back to percent and Paul? Sorry, Jeremy, but Paul is getting absolutely wasted.
I think you're forgetting one of the main things as well, which is the fact that we have, winds and different like atmospheric effects that will push these gases all the way around,
Temperature.
Paul? Where's Paul? Hold on, Jeremy. Where's Paul? How do you respond?
I'm here still.
Ah, okay. Did you hear
But
that?
I don't think he understands that the individual molecules are what makes up the macroscopic properties of the object. All right, so you do have to consider the individual molecules, the properties of those individual molecules.
Okay, so take these individual molecules. Let's take air, for example. You heat up air. Do these individual molecules expand or do they vibrate more?
Sure they do. Some vibrate more than others, though, don't they?
Of course they do, yeah. But the point
and those ones will end up higher in the density gradient than the ones that don't vibrate as much.
100%. But now, if they do vibrate, they take up more space, right? They're taking up more volume, which would change their density. Would it not?
No, it does not change the density of the molecules
Changing the
themselves.
volume doesn't change density?
Changing the density of the molecules themselves. It changes the volume. No, but I am. That's what you just don't get. I am.
You don't want to understand the point. You're just being pedantic.
I am being pedantic because it's getting down to the fundamentals of what it's really all about. The gravity acts individually on each individual molecule.
And if these molecules are together, if they're, clustered or contained, then acts on the group of them. Does it not?
Do the molecules influence each other?
Yes, I think they would.
How?
Well, what if they're more if they're vibrating more or they have more energy, that will also push against the ones that are beside it, right?
Sure. You're saying that they'll collide with each other, yeah?
Yeah, they'll collide with each other, and then if you have if you have more energy in some that are on top, they'll go up and they'll rest on the ones that are below, and that's what creates the density gradient to begin with.
Why don't they equally spread out?
What do you mean? Who's to say that
Why don't they equally spread out? I mean, if they're all colliding with each other in uniform directions, random directions, the same all around, why don't they spread out evenly?
They do. That's why you have a layer.
But they don't, because there's more of them at the bottom.
You have different temperatures.
That's why you have a layer. They spread out equally within that layer, right? And they're resting on what's more dense.
Wow.
That makes sense. Yes. Wow. That's
no, it
stuff.
doesn't.
Yeah, it does. They're resting on what's more dense.
That's literally an indication that they're not spreading out equally in all directions.
That's how you have a density column. That's how you have your layers.
Jesus. He doesn't want to understand. He
does understand percent. That's excellent. Keep going. Keep going.
He doesn't want to move on.
Keep going. Paul, do you
We
concede?
have a layer, just like in a density column.
What?
We don't have.
What?
We have different pressures the whole way up.
No. We have layers, Kosho. We have layers, like percent is saying.
We have a continuum. We have a pressure gradient that is continuous. It's not in layers.
Well, percent, are you saying layers? I can agree with that if that's what you're saying.
Yep.
Yeah, absolutely. And we've seen it because NASA showed us at 50 miles.
It's wrong then if Chemo agrees.
At 50 miles.
Chemo, can I just clarify what you just said?
No, percent is saying it. This is what I've been saying anyway. I made a video on this and showed the different layers going. You get one layer going one way, you get another layer going a different way, and another layer going a different way. We've got this on video, yeah.
Yeah, each gas molecule, each different gas has a different kind of molecule. But
Are they straw man this percent? This is a straw man, right?
Then there's a layer, then there's a whatever layer, and is that what you're saying? Because that's what it sounds like you're saying, and we would actually
understand the difference between a molecule.
You know, it's an obvious straw man when they're like, "That's what it sounds like you're saying."
They're straw manning us, yeah. I thought so, yeah. Mip it.
Oh yeah. You understand the difference? Because this is not a straw man. Sorry, go ahead, Mip it.
Yeah, I asked.
Yeah. So yeah. What they're saying, right? Yeah. So he just said this is like a clump of air, or clump of nitrogen, or whatever. So it's like a group, so it has a different density. He doesn't understand that this is not how that's how gases behave.
Exactly.
It's N2. That's the molecules. N2. If there's no reason for it to make a giant, massive object, a molecule, the air is going to be mixed together. The air mixes up. There's different pressures for a different reason, not because there's a gradient between the densities.
Exactly.
There's nitrogen all the way up. There's oxygen all the way up. CO2 all the way up.
That's not what we observed there, Kosher, right?
That is what we observe. This is exactly what we observe, man.
You breathe, don't you, Chemo? Do you actually breathe?
If you had heat to a gas, is it going to make it more dense or less dense?
You add what?
Let's say you had a container of gas and you get it hot. Is it going to make it more dense?
Hello, Globers.
Holy fuck, Jeremy. No, Jeremy, seriously. Do you understand how a gas bottle works?
No. If we have a tank of gas and we heat it up and cool it down when it's cold, is it going to be less dense or more dense?
Who would do that?
I asked you, do you know? No, Why can't I wanted to answer this honestly. Do you know how a gas bottle actually works?
A container of gas?
Do you know how a gas bottle actually works?
Why does he simple question?
Just say no.
No, because I want clarification.
Hey, Paul, I have a question for you. So,
Bottle.
Paul, you said that the air is colliding, right? The molecules are colliding.
Why is percentage bombing in here?
No, because we're carrying on with.
I mean, it wasn't a great combo,
Davos is
but
just
somebody
derailing.
was in the middle of asking Jeremy something. Is Jeremy bailing? And that's not really the big point, whether Jeremy's bailing or not. The big point is, what the fuck is wrong with these mongoloids that just pay absolutely zero attention to what's going on and just think, oh, I'll go. I'll talk now because I feel like it.
Tell us how gas bottles
It was
work.
quiet. There was a lull in the conversation.
I'll give you the floor.
Because Jeremy, I would ask you. Because Jeremy, I would ask you: does heating up the gas bottle change the mass inside the bottle or the volume of the bottle?
No, that's a red herring.
It's not a red herring. It's not.
If we have a container of gas, and we heat
Jeremy, that's directly related to your question. It's directly related to your question. Does heating up the gas bottle change the mass inside or the volume of the bottle?
Change the density. That's what I just asked. Heating up a gas container, make it more dense.
No.
Heat a gas up in a container, doesn't get more dense.
No.
So the question is, why are you operating under that misconception, Jeremy? Who told you that?
So if we change the temperature, it doesn't change the density of that container?
No.
Okay, so the full volume of the bottle is not being changed, but the volume of the gases within is.
No. Doesn't make sense.
That's retarded. Because if you're not changing the volume of the container, how can you change the volume of the gas?
Because again, the bottle's taking the same amount of space, right? But you're heating up the gases inside, and they're expanding.
The mass is the same, the volume's the same. Like, I don't know. There's nothing else to say, but the mass is the same. Volume don't make any sense.
The volume does not. No, the volume does not change. Yes, the pressure may change, but the volume doesn't change. Because if that volume changed, I would hate to be trying to light a fucking acetylene torch.
Yeah, but ideal gas law, P equals V, PV equals NR.
Yeah, but that doesn't work.
You're changing
once
the pressure's changing.
That doesn't work the way you think it does once you've got it in a fucking bottle.
No, that's not expressing density, man.
That's not expressing density, and you're keeping V and N the same.
Percent is a killer at this, and you guys don't like it, right?
No, he's got it fucking wrong.
No, I don't.
Killing us when he says that the volume of the container stays the same, but the volume of the gas doesn't.
He's asking questions.
You're joking.
He's asking questions.
What gases are inside this bottle?
That's irrelevant.
It doesn't matter.
Yeah,
the volume is the same. The density is the same.
But the individual gases inside.
Hold on, Drus. Don't just de-roll and
total,
change.
they're the same.
Drus, wait.
But in terms of like the different gases themselves, like in air, you have nitrogen and oxygen and stuff like that, and some are going to be vibrating and like more energetic than others.
So I just want to change the shape of an N2 molecule. Quick question to percentage. Got to go run away again in a second. So percentage. If we've got something of a fixed volume, like a container, and we increase the temperature of the gas inside it, does the gas volume change, or does the pressure increase because it cannot expand?
As a total, the volume won't change, but of the individual gases, some are going to be more excited than others, and there's going to be a gradient therein.
No. Stay right there. There's going to be more excited gases, and somehow this is going to lead to, even though you just said the volume stays the same, some type of difference in mass or volume. Because here's the spoiler alert. There's no difference between the mass or volume. The density stays exactly the same.
Let him respond.
When you heat up a gas, it's less dense.
Gets hotter.
We can explain.
When you heat up the gas, it expands, takes up more volume, thereby decreasing the density.
Yeah,
not in a fixed volume. It doesn't.
Within that fixed volume,
that gas that's more excitable
this
is going to take up less volume as per the rest of the gas, which is going to
go ahead and measure this and write down the numbers, and then feel stupid when you realize that what you're saying right now doesn't make sense, dude.
Okay.
The volume's
that some gases aren't more excitable than other gases, Kosho?
What's the equation going to look like? How is the density going to be different in these two equations?
Like, I'm telling you, the density of the whole is not changing.
This isn't
the volume of the whole is not changing.
Kosho, can you just let Percent and Paul get to a conclusion? It looked like they were getting somewhere.
Bro, go shove your face in the fucking toilet.
I know it's hard, Kosho, for you and the Ball Earthers. I get it. But if Percent is exposing Paul's information, we need to hear it.
Selfie swirly, go do it. Do what Kosho said.
Yeah,
now.
you just want to gatekeep. That's all. When he's getting somewhere, that's all. Like, we see what's
No,
going on.
you're gatekeeping, Chemo.
You're doing
You're
it.
gatekeeper.
Chemo.
Stop it.
Chemo.
He's
are
telling
you
you
the
things
chemo
you've never obviously
gatekeeper?
heard before, and now you're freaking out.
And
You're
another
just
thing you guys
being,
should consider is that it
Freaking
also
out
depends on the
because
container
egotist.
itself.
card is ruining the VC.
Okay, go
So
ahead,
it also
Percent.
depends on the
You're not
container
doing
itself.
anything about that,
It,
Chemo. You're
Curve,
letting
one
him
second.
just shit all over the place.
It also depends
Why
on the
you do
container
that,
itself as
Chemo?
well. If the container is pliable or like, you know, more
Chemo, I
elastic,
asked you a question.
then
You can't hear
the
Percent.
gases inside
Just
expanding
shift
will
the
also increase the
fucking
volume.
goalpost percentage. Just shift the fucking goalpost. Go on, do it. Move it as quick as you can.
No. But to be
No, I
fair,
said
he's correct on
keep
that.
that.
If we're looking at a balloon, he's
Correct,
right.
Tress.
A balloon
I'm
has an
saying-
elastic property.
Yeah, he's right on
and it
that,
will
but that
increase
wasn't.
correct.
I
But
don't
that
agree with
wasn't.
that.
But that wasn't the original
But that
question.
wasn't the example. We're talking about a gas canister. We're talking about something with a fixed volume. And when we
Oh, like a
increase
metal
the- and
canister?
when-
Okay, yeah,
and,
you won't see
yeah,
it.
yeah,
Shit.
yeah.
You might see it in a thin plastic bottle.
So I'm talking about a fixed volume that we've got. So when we've got a fixed volume, if we increase the energy in that system, we increase the pressure. We cannot increase the volume, and that is a necessary requirement, as you described under the ideal gas law.
100%. Yeah, if it's
Cool.
like the
Okay,
total volume, it won't change at all.
Yeah, then
Now, to get back
we're in
to
agreement.
Paul's
I'm happy.
question.
What was the question? Too many people
Density
talking.
remains the same, I guess.
What about the potential? Do you change the potential of the gas at all?
Hey, Denmark.
What do you mean by the potential?
Hey, what's up? What do you mean by potential?
No,
That's
what
the
do you
question.
mean? You're the one.
Look
You're the
up
one
the
that asked
definition,
about.
retard.
Look up the definition. You're the one that gave me the
Guys,
question. I want to know what you mean by the
Let's
definition.
not go into the invective. So yeah, you're right. I mean, from the point of view, when you increase the energy, you're increasing the kinetic energy of those molecules. That's why we get an increase in pressure. You could say that by increasing that pressure, we do have then a potential energy of when we release that pressure. So on that, I would agree with you, Dan.
But the game we're just
Is
talking about.
that where you're going?
My
So
point.
that's fine.
Yeah, that's okay.
We're not talking
Me
about.
too. That
There's no.
makes
Guys,
absolutely
you
correct.
understand what we're talking about? Does anybody understand what we're talking about? We're talking about the fucking. We're talking about the
Let
gas
Kosho
pressure.
speak, guys. Go on, Kosho.
Well, shut the fuck up, dude.
What you gotta say?
Shut up. For fuck's sake. You should remember what we're
Kosho,
talking
you're
about
in a
because
bad
you
mood
were in a
today.
conversation. We're talking about the fucking atmospheric pressure.
Mm-hmm.
We're talking about what causes the difference between the pressure down below and up above.
All right, here
Right?
we go. It
Let's
gets
stay on
colder.
track here.
Colder the higher you go, right? The gas is going all around. It's trying to fill the container. Goes up, gets colder. Cold air falls, hot air rises, and there we go. There's your gradient.
Why is the gas less dense up there where it is colder?
It's colder, so because the sun heats the ground, right? You guys say sun doesn't heat the air.
It gets more dense too
So the sun's
after it hits zero.
The
Go
sun's
ahead.
heating the ground. The sun's heating the ground. So all the hot air is down. All the hotness is down here. The colder up you go, the higher up you go, the colder it gets.
And the gas is denser down here where all that hotness is, as you say.
Yeah, because it's all the
backwards
gas.
to your previous claims. Jeremy, you're arguing against yourself here. Just
That's
keep
where
that
it's
in mind.
created.
No, what about the
Continue
Van
on,
Allen
created
belt?
down here.
What about the heat of the Van Allen belt? What's
And
that?
everybody else join in. Everybody else help.
It's more dense than
Just
that.
attacking
here's
Jeremy,
the
that's
thing.
why.
Nothing's denser than Demok. But Jeremy, understand you're arguing against yourself with his argument. Please carry on.
Air can't go up high enough because it's so cold that it always has to fall back down. It's always trying to go up and always falls down because it's cold.
You just didn't make any sense just there. You
Why?
just didn't make any sense. Curve just said that you're saying it's more dense where it's colder. It's colder up there. It's hotter down here because it's hot. It gets
less dense.
heat rises. It's be going up, but it's cold up there.
What's your
Which
problem?
makes it fall back down.
You're not looking at the picture, at the big picture, though.
What's Kosho's
You're
problem with
taking
all? Now, hold on.
individual things
What's
that
the
you've heard,
issue, Kosho?
and You're
What's
trying
wrong?
to universalize that to everything.
We all know hot air rises.
You don't understand what's going on.
We all know
What's
hot
the
air
problem?
rises and cold air falls.
Yeah.
This is a fact.
It's not created up there. It's created down here. So what's the problem?
Plus we have the dynamic systems. All the gas cycles happen at the ground level.
You have
I mean,
empty rhetoric.
I can prove
it's
that.
not rhetoric. It's,
You're not willing to test it.
all the gas is hot. Hot air rises. The sun's heating the ground. The gas down here gets hot. It tries to go up. It can't because it's cold up there. So it gets
In a seal
more
container,
dense and
there's a
falls-
gradient.
When air gets colder, it gets more dense and it falls back down.
Come on, Jeremy.
Where's the
that's a
cycle
primary
in my
school
seal
explanation.
container, Jeremy?
You don't like my explanation of the gradient?
Jeremy,
What's the dynamic?
Jeremy,
It's-
where is
it's a
this?
bit-
Where is the dynamic in my seal
Well, where's the
container?
sun in your container?
It's a bit oversimplified and wrong.
Where's the sun? Where's the weather system in your container?
It's not there, but there's still a gradient. So all those things are eliminated.
Are
Yeah.
most mountains covered in trees, Jeremy?
Some of them, yeah. I don't know. Most of them, I go.
Are
with
there
yeah.
usually more trees on mountains than on the ground at sea level?
I don't know where this is going. Let's just say yes.
Why isn't the pressure greater in the mountains than it is at sea level?
Well, most of the air comes out of the ocean itself, so most of the gases.
Where does it come from in the tube, Jeremy?
Yo, you prove there's a gradient in your tube, Moyak, and then we'll carry on.
I can prove with
Until then,
air.
you're
You're
making a baseless.
I'm willing to. Jeremy, I'm willing to make the test
can
with
prove it, Jeremy.
atmosphere, but not with helium because
You're
I
making a
can prove it.
baseless claim.
You're right, Jeremy. It's baseless.
I can show you that the gradient is in the tube with atmosphere. If you got to pony up money for me to
Why?
go,
That's nonsense.
I can do it for you, Jeremy.
It's a silly
What,
problem. You
you-
pay
you-
for
you
my
shake-
experiment.
Oh
You
no,
shake it.
Jeremy. See now, Kimo, you don't understand. I am telling you that, or I've been talking with him about this, and the bet is, or the thing is, if he's wrong, he pays for the experiment. He's confident of his conviction, so he should be not worried about the $80 he's got to spend, or $600, depending on whether he wants his clear tube or not. But I can prove it right now for free with just atmosphere.
Because that chemo, I think when you fill a container up and have nothing but helium in it, that there's not going to be a gradient. He thinks there is going to be.
And
a
you won't bet
gradient.
for you won't spend $80 to find out.
All right, he thinks there is going to be a gradient.
You
It's
won't
his
spend
claim
$80
in the
to
first
find out.
place. It's
No,
his
I know
claim in
there's
the
a
first.
gradient. That's
Come
why
on.
I don't want to
Come
pay
on,
for it.
Wyatt.
It's your claim. If you care, you do it.
No, and
Stop
I
trying to
will do
corral
it.
people
I'll
into
eat the cost if I'm wrong.
stupid
He's got to eat
shit
the cost if he's
experiment.
right.
They don't even trust your results
it's your
anyway.
claim that there's not a gradient, so you do it.
No, it's
Yep.
not my claim.
It's your
I've heard
claim
you
that
for the
there's
last
not a
20
gradient,
minutes.
so
Try and
you
pretend
do
you
it.
know what's inside
You
a
got to
gas
do
bottle
it
and
because
inside
it's
a
your
balloon.
claim that there's not a gradient.
You have no idea how it works inside gas bottles.
You
You've
have
never
no
tested
idea
it.
how
Sure
it
do.
works outside of a gas
Preaching
cylinder.
bullshit.
I've done
preaching
it inside
bullshit
a gas
again.
bottle with atmosphere. I
Get on
haven't
with the
done it
test
with
if you
helium.
really give a fuck. If not, stop preaching it.
Hey, Jeremy.
no.
So
Timo,
anyway,
you're a
guys,
coward.
hang on. Fuck's sake. So Jeremy, you shake a deodorant can for a reason, right? If you had a deodorant can sitting on the shelf for days and days, and then go and spray it, then shake it and spray it again.
That's aerosol. That's not helium.
So what? It's gas pressure in a container.
That
Liquid. That's a liquid in that can.
yeah, I was gonna say, is that liquid in there or is that all just gas?
It might be a bit of both.
How much
Yeah.
pressure is inside a balloon when you blow it up?
Depends what you blow
I
it up
don't know.
to.
I don't know. You could probably do 0.1 or as much as high as the
So,
balloon
for
can
example,
handle.
if you put 30 psi, then
What
you've got
would you
30.
estimate the pressure inside just an ordinary party balloon would be?
Wow, we're looking at, like I say, 30 psi plus 60. Depends how big you want to put it up to, right?
How much pressure's inside your car tire, Chemo?
I thought you were talking about one of those giant balloons, no?
No, I said a party balloon. Jesus.
I have a big party, yeah. Okay, just a regular balloon. Yeah, you got like 10, 5, who knows?
I'd say 2. I don't
It'd be
know.
more like less than 1.
All right. What's the point
Depends
of
on the
all that?
balloon,
The
right?
point is that when you pop that balloon, how quickly does that pressure equalize?
Immediately,
Instantly.
right?
Instantly.
Immediately, right? So if I've got a pressure differential of like 10 psi, wouldn't I expect that to equalize pretty rapidly?
Well, you can't win on this one.
What are you
I
talking
can.
about?
Well, I'm saying that if I've got a pressure differential then of 10 psi, wouldn't I expect the 10 psi would rush to equalize with the pressure that's 10 psi less than that? Wouldn't that air try and equalize pretty quickly? I mean, if a party balloon's got less than...
Can you just get to your point, please?
I am getting to my point. If a party balloon's got less than 1 psi in it, and when you pop it, it rapidly expands and equalizes the pressure, how much more quickly will a pressure differential of 10 psi equalize?
I mean, it's going to be, the pressure is going to, if you start popping balloons, the gas in the balloon equalizes like near instantly. So it's going to be negligible. The amount.
Yeah. So if I have a whole heap of balloons on my floor, and I pop them instantaneously, would I expect to measure a higher density at the floor?
5%.
I mean, come on, I'm creating all that gas at the floor.
Got to catch us output.
Are you saying that you'd have to be able to hover if this was gas cycle was the cause of the atmospheric pressure?
Did you hear my reasoning for temperature? The temperature helping cause it? There's a lot of factors. This isn't like one little thing where you can just say.
But you're not willing to test it.
There's temperature. You know, the hot air rises. It's colder up there, so it gets more dense as it goes up and falls back down.
Is it colder in my tube?
I think you're willing to suspend reality when you claim that a pressure differential of 10 psi over a distance of 8 kilometres isn't going to cause hurricane force winds. Much less pressure differentials than that in the atmosphere cause severe winds, high velocity winds. So why aren't we seeing a massive wind rushing up?
Because it slowly trickles up because it was contained. That's why.
Hey,
by the way, I had you muted, so I couldn't. I just watched back the debate with me and Paul, and I heard you saying stuff that I didn't hear during the debate. So I didn't realize I had you muted, and I heard you giving me warnings that you were going to mute me and stuff. I didn't hear one thing you said, so I've unmuted you now. So sorry about it. I didn't
You're
know
lucky,
it's
mate.
automatic.
You're very close to getting muted.
It always happens to you. Why? I don't know why. It just automatically mutes you, and I didn't know that. I didn't hear you in the whole debate. But
That's
I just thought.
That's because you think I'm a cunt.
Nah, well, I like cunts. They're juicy. They feel good. You know what I mean? They arouse me. But I want to go back to Paul's
thing to say.
It is a bit, but. Paul, I just hold on. I wanted to ask Paul one thing before because the debate I've just watched back, he's still right straw man me. But the point being, he said that special relativity has nothing to do with general relativity. When I clearly said that when you put a body of mass on top of special relativity, it becomes general relativity. And he said that they were nothing to do with each other, and he hasn't given me an answer why that's sufficient or not. So I'd like to hear Paul's expert opinion.
Saying that when you put a mass on top of special relativity, it's not really the right way to say it, okay? Because when we're talking about masses, we are automatically then talking about general relativity. Special relativity doesn't deal with masses. It doesn't deal with curvature of space-time at all. So if you're talking about masses and special relativity, they don't go with each other together. That was my point.
Well, my point was that special relativity is just the fabric of space-time, the blanket of it, right? That was just nothing to do with the masses. But it says when you introduce a large body of mass into space-time, which space-time is the special relativity, then it will bend and warp, giving the illusion of an attraction, right? So you need to understand that's what I said, word for word. What you then took from what I said was special relativity has nothing to do with curvature in space-time. Like, do you understand how you straw man me?
No, you're straw manning me right now because what I'm telling you is that special relativity doesn't talk about the fabric of space-time.
Well, it is the fabric of space-time because it's the three different. All right. So general relativity, special relativity has nothing to do with space-time. Is that what you're saying?
General relativity has to do with space-time and curving of space-time. Special relativity doesn't.
Oh, nothing to do with curving space time. But does it have?
No.
The question was.
No.
The question was.
No.
The question was. The question was. The question was.
No. The question was special relativity. Special relativity. Special relativity. Special relativity. Special relativity. Special relativity is about time dilation and length contraction.
Special relativity is about the dimensions of the fabric of space time.
No.
No. Okay. So So it's nothing to do with space time. That's what you're saying. Special relativity is nothing to do with it.
It's got to do with space time, but it's not got to do with curving of space time.
I never said nothing to do with curving. Did the word curving come out my fucking mouth? You idiot!
Yes, they did.
Stop straw manning me. Shut your fucking mouth. Listen for once in your shit life. Listen to the words that are coming out my mouth. Does special relativity, yes or no, have anything to do with space time? Don't fucking beat around the bush.
Special relativity has nothing to do with a fabric of space-time.
Okay, well, there we go. Thank you very much.
Paul?
That's all I wanted to get through to him. That's it. I'm done.
Jesus.
You brought up curvature when you brought in mass. That's
exactly.
I'm just highly impressed that Paul admitted you need a container to weigh gas. That was good of you. None of the other Globers will do it.
What's so special about that?
I don't know, but they would never.
I've got a question for you. I've got a question for you now. I've got a question.
Can I just make my comment, please? I've been driving for the last 5 minutes or more. Paul, I'm considering the overpressure thing in the atmosphere. The only place I can think of where you're going to get a 10 psi overpressure is within about 5 kilometers of a 50 of at least a 50 kiloton nuclear weapon going off.
Yeah.
That's about the only place. That's about the only time and place I can think of in the atmosphere where you're going to get a general overpressure of
volcanic caldera going off.
Well, yeah, or something of that equivalent.
Yeah. You need some sort of
energy
pretty good disaster to happen.
Yeah, and I'm sorry, but the answer of the gas just slowly trickles up doesn't do it.
In physics, the special relativity theory, or special relativity for short, is a scientific theory regarding the relationship between space and time.
Wow, it doesn't say fabric of space-time.
Does it say fabric?
What is space-time? Explain space-time.
Space-time is a 4-dimensional space-time. It's not a fabric.
Space-time, isn't it? That bends. That's the actual bending of warping of space-time. Is the same thing, you spastic?
Can I ask my question now?
Go ahead, Jim. Go.
I'm jumping in.
Listening to each other, trying to clear something up.
No, and again, the warping of space-time is not special relativity.
Can I ask my question now?
Never said it was. Never said it was. When you introduce a body of mass to the special relativity, it becomes general relativity, you fucking idiot.
Special relativity is simply explaining objects moving through space and time, and it's just describing how time changing.
Can you prove that? Can you prove that and give us a demonstration? Can you? You're just saying it. Can you prove that?
Yeah. I mean, we accept what you're saying, but can you prove the equation?
On Earth. Yeah, on Earth. I don't want the fucking maps. Physically. I want to know how that relates to an object.
I don't know what it is this morning. I have a real problem dealing with you retards today, dude. I don't know what it is.
So the only the only person who needs re-educating is the globe earthers, Kosho, who think that space and time is a cause of acceleration.
Bullshit.
Okay? So, I mean, you can call us all the names that you like and be as offended, but this is not our problem. This is your problem who decided, yeah, we're going to believe something that we can't demonstrate. You see?
What, like a container holding the atmosphere and you can't
I'm saying to
demonstrate
Kosho
that, can you?
I'm saying Kosho getting very upset because he's like, you know, you guys like this and that, and I'm like, well, okay, can you demonstrate your theory and then we can accept it?
Your assertions.
You guys are
they're not even theories.
You guys are
It's
saying,
just fucking assertions.
you guys aren't this retarded. If you are, you should really stick your face in the toilet and not take it out. But you're not this retarded. You're fucking all just lying about all this bullshit.
What did you say? The heliocentric model's going down the toilet, did you say? What did you say?
It's shit. You can't. Hang on a second. You can't prove anything you say. You can't demonstrate it. It's not verifiable. say it's crap. What you're talking about is shit. You can't prove it.
Pretty unreasonable demand. It's pretty unreasonable.
It's pretty unreasonable considering you can't prove a single iota of the flat Earth.
The flat Earth.
Pretty unreasonable. It's a pretty unreasonable demand to demand a demonstration of that over the internet, isn't it?
No, everything is on YouTube. If you got a demonstration or experiment, if it can be done, if it's possible,
correct.
you will find
There's
it on
plenty
YouTube.
of stuff that isn't on YouTube.
Like what?
Oh, how about the citation that Jen put the other day?
It's not on YouTube.
Why
Correct.
is this gas?
It is not on YouTube.
Why is this helium tank with a gas pressure gradient where it's more dense at the bottom not on YouTube?
Kosho is angry.
Yeah, Kimo, because you're a blatant liar. And yeah, you're teaching these other guys who are much more honest than you are that it's okay to be a liar too.
It's never okay to lie, Kosho.
So Kimo, I'm looking on YouTube right now, and I'm seeing a whole bunch of videos about flat Earth and the different models that they pose. Which one's the right one?
Again, these are just projections of individuals who believe that this is how the Earth may or may not look. Now, you can have your own projection.
Which one's the right one? Because YouTube is the nexus of where information lies.
Well, being as you were, I mean, I kind of like what. If you ask me what do I go with, I kind of like what Jaren describes, where we have this own personal sun. So the model that models the personal sun, and that sounds the most plausible at the moment.
We don't have a model. We don't have a model.
But, yeah, we don't have a model. That's the point. That is a reification.
We don't have one.
We don't have a model. I know that. But the idea is that somebody might have a projection. Yeah, but I'm saying that somebody could have a projection in their mind of what they think the Earth looks like. It doesn't mean that it is Nidhogg, right?
It doesn't mean that it is, correct?
It sounds like you can't demonstrate this model at all. So why should we?
We don't have a model.
It doesn't say we. No, it's not that we can't demonstrate it. The point is this: your curvature cannot be found. All we find is a leveled plane. That's what we find when we do the measurements and do the experiments. Yeah, that's what we find.
No,
we don't find the rotation of the Earth, nor do we find the curvature.
It sounds like you need to stand up with your convictions then. And if you have all these measurements that are so precise and so accurate, you should be able to make a model out of it, don't you think?
Bring us some evidence.
How can we make a
models
that sounds like
hold on a second.
Someone's lying here.
We'll just shout it.
Your model doesn't exist. Your model doesn't exist. Your model is a fucking
Your model doesn't
joke.
exist.
And Copernicus didn't want to release it. Copernicus, no, it doesn't exist. Your model exists in reality. It doesn't exist. It doesn't exist in reality. It exists in head.
Do you
in your
have rabies?
That's where it fucking exists. Your
So,
home.
full of it tonight, aren't you? Holy crap!
Now,
Nidhogg, we you know, you've heard the expression.
something
Models
called
are like a
in your ears if you can't
reification.
take it.
The fallacy,
Sort of
right?
kitchen
So if I
get out.
present a model or you present a model,
That's
how on
what
earth?
you want to say, but it's not true.
Hold on a second.
Wait,
Nidhogg,
Chemo's
please.
going to present a model of the flat Earth?
But I'm saying if anyone presents a model, Nidhogg, they're reifying what they believe to be true without actually going out there and taking any measurements or verifying what the model actually is, right? So that's why we don't live on a model.
Guys, 1 second. Point of order. Point of order.
But Nidhogg, look, you're interrupting Nidhogg here. He asked a simple question, trying to respond, and I want to see if he wants to respond
you've
to it.
just
So,
made a complete balls up.
Nidhogg, do you understand the point when we're saying that it's a reification fallacy? And that, you know, unless someone's actually been out there and they can verify that they've been out there.
Reification.
Hold on a second, Josh. You're talking all over me, Josh. Kosho, why aren't you Oh, thank you. Thank you. See? So they're good. Kosho's a good mod. He's a great guy. So look, Nidhogg.
I would like to ask. Oh, he's not in the room. Sorry, don't worry, no worries.
Yeah. Nidhogg wants models. We don't live on a model. No one can go around the entire place to verify if that's actually true, Nidhogg. So you're just presupposing what someone's presenting to you. You see?
I want to speak to this model thing.
First off, never said you lived on a model. That's just made up crap for you. And secondly, if you can model something, you can do it by measuring. You can model anything if you have exact measurements. It's nonsense to say otherwise. You can model literally anything if you have data and you have measurements. And to say otherwise is just you smoke screening because you got nothing, buddy. You got
All right.
nothing.
I want to speak to the model thing now.
Perfect,
Everyone inside their head has a model of the world around them. So I mean, there's 7 billion, or how many people are on Earth? 6 billion. There's 6 billion models of Earth right now. Whose do you want?
Exactly. That's a good point, Nidhogg. So there are different projections, is what we're saying. Which
one
one
that can predict
you say
everything.
this one? You say this one comports with reality, but what we find is that your model doesn't even comport with reality.
About models.
You don't have a model, and you don't comport with reality. So, what's your point, Chemo?
6.99 billion all believe in one model.
Nidhogg, you understand? So if you
have
try
a
to provide a model of the sun being 93 million miles away, if you went out and actually measured it, you would find that it's not 93 million miles away. Okay?
That's a bold claim. How can you prove that and back that up, Chemo? Because that is a bold declaration.
If you say, for example, our model says the Earth is 3959 and the horizon should be, at a certain distance, we find in reality it's not where you say it is, Nidhogg.
Back that up, Chemo. How can you say with certainty that the sun is not 93 million miles away?
Again, has anyone measured that?
Yes. We have used instrumentation to measure it.
Well, that's what people are questioning, right? How are you measuring the sun, the distance of the sun?
Chemo.
Well, I mean, I think you'll find every day people are curious of how you found out the distance of the sun.
I think you'll find it wrong.
Chemo, do you have the answers of how to actually measure the distance to the sun, since you're so skeptical of something that is
one way I suppose would be triangulation,
It's an accurate way.
Yeah, like you get the sun. You get the sunlight when it's overhead, and you just try and form a triangle. Or when those corpuscular rays are shining down, you form another triangle and just work out. It's around 3,000 miles, something like this.
So you're gonna stand behind the sun being 3,000 miles away.
Around. I think it's 2,000.
Corpuscular rays show it at about 50,000 feet.
Well, like I say, you can make a triangle. You can work. That's one way of working it out. But again, how will you know if that's true unless you go to the sun?
Somewhere over England.
No, I'm saying we won't be able to. Even if I did that, you would say, "Well, this is wrong. That is wrong." If you do it, what?
The sun's somewhere up there by England. Is that what you're saying?
No, if you want to speak to someone who does geometry, like I say, you've got Bev, you've got Rakia.
You see that, yeah.
Even Jeremy can work out the angles if you need him to.
You know damn well the sun's never directly above England or even remotely close to it. So why would you use this stupid corpuscular ray example as evidence that those things are going to the sun just because you don't understand it?
You've got to form a triangle curve.
Why are you so stupid?
Right. 50,000 feet.
Chemo, they actually have a serious problem, this triangle business.
Mm-hmm.
It comes to find out, Bev was in here the other day.
Yeah.
And he told us that you can't even get an angle if you're on a curved surface.
Okay, well, we're on a flat surface. He still doesn't work. So what's the problem?
Whoa.
What do you mean it doesn't work? Of course you can have a triangle on a flat surface.
Shut up, Chemo. What angle can you not get, Jeremy?
You can't measure the angle of the interior angle of a triangle if one of the lines is curved.
Oh yeah.
Hey Jeremy, you said DM it to me. I fucking DM'd it to you, cunt. Did you look at it?
I never looked at it yet. Not yet.
So Chemo, are you seriously telling me?
I'm not even kidding right now, Jeremy. Fuck you.
I'm not an expert on the triangles. We've got experts. Look, if it comes to pressure, I'm your expert. But when it comes to triangles, we've got people in that department who will give you all the triangles.
Chemo, you did a good job, Chemo. You did a good job, Chemo. You did a good job.
Chemo, you're trying to tell me that the sun is only 3,000 miles above the surface of the Earth.
That's what the triangle says.
Yet we have measured the moon.
That's right. 3,000 miles. 3,000 miles.
245,000 miles, give or take, because obviously it changes on its orbit because it's slightly elliptical.
The moon.
Yeah,
the moon is not 200,000 miles away. No way, is it?
Yes, it is. Yes, it is. We've repeatedly measured it to be that distance from the surface of the Earth.
No, again, you know, I mean, we don't know what the moon. We don't even know where the moon is. Who's
You have to back up that claim.
It's not that far.
Oh, you
no, it's not. The moon is not that far.
Okay, then what do you have to back up that claim, Dan?
What we need is someone like Kosho, because Kosho can do this, but again, he just won't do it. If he goes out there and makes a real triangle with the moon and the sun,
not that far.
He will get an answer.
I know
people. Why are you talking about triangles when you already declared that you're no expert upon
That's
triangles?
what I just said. Yeah. Kosho could do it. He's the guy that can work these things out. But like I say, there's something else going on, and like that prevents him from going out there and
how
looking for
we have measured the moon's distance to be in the 245,000-mile range. And it is done repeatedly, and I know somebody who has done it.
No, like I said, if Kosho went out there, measured it, showed it on, on camera like he does, well, we would have something to work with. But the people who know the maths are not doing it. They're just giving up.
Because they know that we have used radar to measure the distance of the moon.
The video is there, and it takes you through how the flat Earth model, as he calls it, destroys the globe model. Why don't you watch it?
Is now a flat Earth model? How does that actually comport with what you previously said, that there is no flat Earth model?
No, the globe model, I think. No?
Yeah. So, Chemo.
No, you're exactly the flat Earth model.
Chemo, can you please explain how we can use radar to measure the distance of the moon to be 245,000 miles?
Well, again, you're going to have to demonstrate that your radar. Catch you later, Mippet. That your radar is actually firing and hitting objects that you say they're hitting. For example, so you're going to have to show the radar hitting like a tree, and then hitting a boat at the horizon, and then it can hit the moon that's beyond the horizon. So let's say the moon is setting at the horizon.
All of the time.
Alan, let me speak. Alan, come on, you asked me a question, Alan. Let me answer it in full. So if you could show when the moon's at the horizon.
All of that has been done.
Yeah, if you could show the moon at the horizon, and then
done.
If the moon,
and I have no wish to do it at the horizon. I'm going to do it when the moon is up high in the sky, so that I can be absolutely sure that the object that I'm getting my returns from is the moon.
No, because you can do it as it's setting, as it's going down. You take one reading, as it goes down a bit more, you take another reading. All the way, and then, Alan, look. Alan, look. Try to listen a second.
You're a fucking idiot.
I've just listened to you.
Why are you now moving the goalpost?
I'm trying to be clear so we can accept what you're saying. I'm not hand-wave dismissing.
Why are you going to move the goalpost?
Kosho. Where's Kosho? See, when they're attacking us, Kosho, you let this happen. Right? You allow this to happen, and then you blame us for causing the trouble. Alan's asking a question, and I'm saying to Alan, if he can show that his radar has hit the moon, and then the moon sets, and then it doesn't hit them, like he fires it in the same place and it doesn't get any reading, then we know that he's hitting the moon and not just something else.
Wrong.
You see, Alan, very simple.
Wait, Alan, we don't need to do that at the horizon. We can do that, say, at the zenith, so we can have our radar pointing up to.
We use a narrow-beamed radar signal.
Exactly.
We sweep it across the sky. We get no return. It's now pointing at the moon. We get a return. It's now no longer pointing at the moon. We don't get a return. There you go. Perfect.
He's basically saying, does radar work? That was the question.
And he's saying no. I know. That's
and that was why you got annoyed. And the other thing I wanted to say is having a model is not reification. I can have a map, which is a model. Yeah. If I say that this map is England and it's the actual country of England, that is me trying to make that model concrete. So that's where you get into reification. So to have a model to represent something is not reification. And you guys really need to understand your fallacies, because I very rarely hear you employ them correctly.
And I'd just like to say that somebody has posted a link to a YouTube video of this being done, and that person has also personally done this.
What they've done, they've
Oh,
they've
no.
fired a radar to the moon, yeah?
Yes.
Timestamp.
He's posted the video.
Okay, the radar
He's
things are being
posted a whole
Let's move
video
on,
on the
please.
entire subject.
Let's move on, please, because the radar has actually been affirmed it's working and chemo seeded. So let's move on to the actual question about the flat Earth model that Jin referenced. Let's move on to actually doing that. Provide the flat Earth model. Provide demonstration of it.
What a demonstration of a model. Oh, go on.
Can you hear me?
Can, yeah.
Oh, you can hear me, can you? Right. Well, if you
Sadly.
look 5 minutes up, if you look 5 to 10 minutes up, I posted it twice, so it's there already waiting for you. Okay.
Thank you.
It's Flat Earth Banjo. Flat Earth model destroys globe Earth model forever. Is the title.
We have a model now.
Okay, and I tell you, it's humiliating. I'm not claiming there is a model. That's his video. If shut up and let me finish what I'm saying. When you look at the video itself, it basically challenged you globers to actually make a model that works, a working model. That's what he's going to that's what he's got there, a working model. And he challenges you globeheads to actually make a working model, a ball that's spinning with water sticking on it, and you can travel around on the globe. That's what you're going to see, and you ain't going to be able to do that. That's the humiliating thing about it.
What's the global response to
the flat
that?
Earth model, and he shows you how you circumnavigate the Earth, everything on his model. Yeah, right. And then he also puts inserts about how the globe is impossible. So you've got a mixture there, but there is a challenge at the end. You're challenged to make a working model with water on the Earth, sticking to the Earth on a model, working, and working model. Let's see you do that. But that's what's brilliant about this particular video. Fantastic.
It's fucking hilarious.
The fucking glowheads. It humiliates you completely, forever, because you can't do it. It can't be done.
Such a daft request.
You see what I mean? Did you hear that? A daft request. We have good standards here. Standards of honor, integrity, and intellectual integrity. You guys have none. None you have. Not one shred.
Okay, so guys, what is the...
as soon as I mention the video, they're very interested in the video.
So
if anyone can watch it, it's just humiliating.
Yeah, I've got it on here now. I'm watching it right now.
Eyes.
And he's pouring water into the, as water needs to be contained. So, guys, what is the problem with this model? This is what we see. This is what we see in reality.
Okay, you asked the question, what's wrong with that model? Let's cover a few things. The coastline of Australia in comparison to the other continents.
That's semantics at the moment.
Hold on.
Semantics.
Hold on, let's let everybody... Hold on, please.
Moon, how that moves.
Mm-hmm.
Where's the actual explanation for eclipses?
Yep.
What about the...
You see what I mean? Yeah, that's just bullshit.
From this model.
Please provide a working model like that one. Provide a working model with your ball spinning with water, not painted on. We don't want it, as he says, we don't want a ball painted blue sea. We want the liquid. We want the liquid on the ball.
Disproving another model does not actually confirm or actually validate the model of the flat Earth.
Please provide your working model. Your working model as a ball with the water all around the continents.
That is not the question, Jen.
Everything.
What was the question, Jen?
The question was, give me your working model.
Negative. That was not the question.
Of your globe Earth.
The question was, for instance, the coastline of Australia there in comparison to the coastline.
Doesn't matter. It really doesn't matter. It really doesn't matter. It doesn't.
Now, hold on. So, hold on, Jin, a second.
We can go to Australia. We can get there. We know you're there. We know Australia's there. That's just bullshit. Get your model going. Let's see you make a model like that. Working model. Where is it?
Okay, then how does
we don't have the globe, and they can't even produce a working model, guys.
Actually operate upon that model of the flat Earth.
A real fucking thing. You can't even produce a
Cowbows,
model.
are you saying that...
letting him do this? I got muted for hardly over talking anybody for about 5 minutes, and you're letting Jin just talk over fucking everybody and doing fuck all about it. Thank
they
you
like
for being
that.
such a
I
reasonable
will
mod.
now shut up and let you speak. I'll shut up and let you speak.
Cheers,
Go
Jin.
ahead.
That wasn't
Sorry.
against you, by the way, mate. It was more against Chemo. So
Cowboys, you're comparing this model with something else. What are you
Negative. Negative.
What are you doing then? You're saying what knowledge do you have about where we live?
That's inconsequential because that's not the question. What was the question?
How do you know this
Chemo?
model is wrong? How do you know what's wrong with it if you don't have something to compare it to?
Actual measurements of what the coastline of Australia is. Actual measurement of the moon.
Okay.
Actual
Well,
measurement.
that's what I'm asking you. So let's see what you're comparing it to, and let's see where it's wrong.
Yeah, where is your model? Where is your working model? That's what we want. They provided one for you. Now let's see yours, please.
Jin, shut up, Jin.
It's like
okay, how about the actual measurement as established by the Australian government of the coastline?
Excuse me, can we not just have your fucking model? Bring your model if it's superior.
Jin,
Bring it in. Where is it?
It's not about another model. We are covering the flat Earth model. Stick to the topic.
This model.
Look,
this model
the whole point
here.
of that video, the whole point of that video is to demonstrate the flat Earth model. So watch it in its entirety, and then there's the challenge to you globe heads.
Up to you
Get your fucking model out.
Any thoughts?
For fuck's sake. Fucking wankers, honestly.
Well, look, are you still there, Paul?
No.
Of course I am. And now you're straw manning me because I said that special relativity had nothing to do with the warping of space time.
I agree. It's nothing to do with the warping of space time as well. But you said I did say that, which.
Fucking hell. Fucking hell.
Just got disconnected then. Still here?
Of course I'm here.
When you add a large body of mass, does that make sense?
Well, man, I think you just broke up. I'm not sure.
Yeah, I think I did. One second. I'll rejoin. Or you can hear me now, actually.
Yeah, I can hear you.
Well, what it did say, can you hear me now?
Yes.
All right. What I did say is that general relativity is like space-time blanket or fabric, right? And when introduced a body of mass into space-time, it warps it. So I was saying it's related in that sense. I wasn't saying that, well, space-time itself has something to do with the warping of space-time. The curvature, sorry. I'm trying to say that when you introduce a large body of mass to space-time, it becomes general relativity. The moment, so it's not actually special relativity that has warping, but when you add mass to space-time, it's general relativity.
Yeah, and I agree with that. But the way you were saying it earlier was incorrect. You were saying adding mass to special relativity. You were saying put mass on a blanket of special relativity, and that's wrong. That's what I was getting upset at.
Yeah,
okay?
I get what you mean.
Okay.
But it's the same. The same thing is quite consistent because special relativity itself is space-time. So when you add mass to space-time, therefore it becomes
No. Special relativity is like Nick said.
Hang on. You're going around in circles.
It's just the physics of
How
fast
does that
things.
relate in the reality we live when an object drops to the floor? When an object drops to the floor.
Because this Jin, the reason I'm so hot on this point is because it was all because about the molecules having a preference to going down inside of a balloon. And then I said, it's because of molecules sitting on top of each other. They're saying, well, it's gravity. Then I said, well, we need to talk about the actual cause of gravity. It's only an effect of the bending and warping of space-time, giving the illusion of an attraction between objects, not actually gravity itself. Then I asked him to explain why general relativity creates a gravity well underneath it, and apparently it's only like apparently I've heard a couple of explanations, but I want to ask him his explanation of why the body of mass that's been introduced into this fabric of space-time gives this object a central gravitational pull to the center of its mass. That's what I'm trying to say. How does that bending and warping of space-time transform into a central point of pulling inwards on a body of mass?
Because it creates, it warps the space-time, and the object moving under that gravitational pull moves along a geodesic. and that geodesic causes the object to move in a path that acts. It acts like a force acting towards the center of that mass. That's just the way it works.
So when it bends and warping the space time around it, it creates like a warping of like a drain, so to speak, or like it kind of makes like a ramp sort of thing for these celestial objects to give an effect of a force when it's not a force, but then it is a force within inside the actual object itself. It's a bit like it's doing two things at once. Do you not see how that's a bit weird?
When we think of objects moving, we don't think of warped space-time. We don't think of warped space. We think of things in flat space or in Minkowski space, okay? So when we think of things in flat space and we ignore the curvature of space-time, then the effect of that is that we have to see gravity as a pseudo-force. We have to see gravity as a force. It manifests itself. It manifests itself as a force if we ignore the curvature of space-time. If we include the curvature of space-time and use general relativity, then you're correct. It's not a force. It's an object moving along a geodesic. But the result of that is as if there was a force there from our point of view. So really it's irrelevant whether you talk about it in Newtonian or Einsteinian terms. They both result in the same thing, which is one object moving towards the other.
Paul knows all this. Paul knows it's not a force. But unfortunately, he gets paid.
Don't muddy the waters, King. I'm kind of getting somewhere with it. This is the furthest I've actually got with anyone I've spoken to about it. Because every time I speak to someone about it, they don't really quite. They can tell they don't know what they're on about. You obviously, I feel like you do know, and I'm happy to learn from you. I'm not arrogant enough to just overtalk everybody and think that I know better than anyone. But what I do think is that we was agreeing when you did explain special relativity and general relativity. I literally said it in the argument on the tape. You literally just explained the same thing I said it, but you just said it in different terms, different ways. Maybe certain words that I said led you to believe that I was thinking of something slightly different, or like I can see now why you thought that I meant special relativity itself was warping. But I'm just saying the actual concept of space time. Anyway, we've gone past that. I'm still lost on the point of now it warps the space-time, creates an effect of an illusion of a gravitational pull when it's not actually pulling the object, but it's giving the illusion of it because the fabric of space-time has been warped, and that's why we get gravitational lensing, because when light goes through it, it's distorted, it's been affected by that body of mass, but it's not actually a gravitational pull, it's just an effect that it does. So when it hits that kind of wave, it kind of gives an attractive orbit. So the celestial object gives it like an orbit sort of an illusion, but then it actually, in the core of the object, creates an actual central of mass, like of actual gravitational pull, which is actually working as a force to your knowledge, and that's what's causing the downward force of like water pressure, molecules inside of a balloon going down, and also working as a container, keeping the gas on the Earth. Now this is where it gets a bit like, how does something that warps a three-dimensional space also give it the properties of a fucking so much stuff at the same time that it just makes me think that maybe it isn't right.
Slow down,
do you get what I'm saying?
Look, Brummy, general relativity is a particularly hard subject to understand. You're not going to understand it as a layman. You know, you're going to have to get some pretty high-level mathematics under your belt to be able to properly understand it. It's even hard to describe in simple layman's terms, you know, and that's why not many people get it, because it is so hard to understand. Okay. But one of the things I would say there, you said something about creating a centre of mass. Well, you don't create a centre of mass. A centre of mass exists for any object. And you could say that each of the individual particles of any body, they all act as individual particles with their own gravitational field or their own warping of space-time around them, you know, and all of these combine to create the macroscopic effect, okay? So for symmetrical objects like spheres and stuff, we can simplify it as if it was a point at the center of the sphere that's causing the gravitational well, you know, but in reality it's not, but that's what it simplifies to if we use the mathematics. But for more complicated shaped objects, it's not that simple.
What about, let's say there's a thing that kind of messes with my head with the slinky. Now, when you hang a slinky out the window and you say that, let's say the slinky, the spring expands because there's a force being pulled down. Let's just think of it as a force, and it stretches out the elastic, the spring, and then obviously when you let it go, it stays in midair, and the whole spring contracts. And they say that the reason the top and bottom are contracting, but at the same, there's two or three different ways to look at it. But the top and bottom are contracting, but you can clearly see that only the top's contracting, and the bottom seems to be still extended and dormant in the air. And obviously it's not being held. And the way if gravity is acting on the entire mass, all every single atom of that spring, then I'd still assume that once you let go of the top, that it would start to decline and contract as it falls. But that's not what we see, because it basically defies gravity, or the tension of the spring also contracts it. And so what's your understanding of that? Because that for me makes me feel like there isn't no force. Do you get what I mean? Because I see that and I think, well, maybe there just isn't a force, because there's lots of things like this that are contradicting it.
Well, clearly there must be a force, because to stretch out any spring, you clearly need to put a force on it, don't you? I mean, can you make a spring stretch out without putting a force on it?
Well, the way I look at it is that all solids and liquids, they all have an attraction down, not because of gravity, because of just the molecular bonds of the atoms. They're very strong, and heavier things seem to take a lower position, and lighter things like air take a higher position. And that's just the nature of the universe. When I go outside, I see concrete at the floor, then I see sea on top of that, then I see the air above it, then above that, it just fades out. Do you get what I'm saying? So I see a gradient in reality, in the real world, that I see in the natural world. So when a spring is made out of a heavy material, and it's not exactly, it's a solid, but it's a solid connected in sort of a pattern, obviously a spiral. Every single part of that would still go down. Like if I let go of the whole thing, it would fall. But if I hold on to one part and let it go, then that to me makes sense, that it just, the dense object would just all try to reach its equilibrium. But obviously it's all attached like on a rope sort of thing. So it just extends like a rope when you throw a rope at the window. So it's no different from throwing a rope at the window as a spring. So I don't really attach this force to it. But I'm assuming a force is doing to it for this thought experiment, to trying to adequate if what I'm seeing is actually a force, or is it just a misinterpretation?
Well, it is, because if you stretch out a spring, does not the spring pull back on your hand?
Yeah, you could. Yeah, springs like they. If you pull a spring out, yeah, it will contract.
Sure. Okay, so if you've got a spring attached, let's say horizontally, to avoid gravity now, right? So we've got a spring attached, or let's say you've got two people, and a person is holding each end of the spring, and you stretch it out, right? So clearly it's pulling on each person, isn't it? Each person at each end feels a force pulling inwards, right? And if one person was to let go, the spring would go towards the other person. But by the same account, if the other person let go, the spring would go the other way, wouldn't it? So there's clearly a force pulling towards the center of that spring, isn't there? Okay, so so it's the same thing when you're hanging the spring out the window. The force of gravity, its own weight is pulling the spring down. Okay, so its own weight is pulling the spring down. Okay, and it's pulling on your hand, but you're also pulling that spring up. Okay, so it stretches out to a certain length. Now, when you let that go, it's going to contract towards the center of the spring again. But the center of that spring is actually falling down. If you were to mark the position of the center of that slinky, you would see that center position is actually falling at a rate of 9.8 meters per second. Okay, and what
catches up with it.
Yeah, and what's happening is that center is falling down, and each end of the spring is actually contracting towards that falling center. So as that center falls down, the bottom is contracting upwards, and it seems as if the bottom is like defying gravity, but it's not. It's actually contracting towards the center of the spring.
That's what I said. Yeah, it's supposed to be like contracting both ends, but obviously it's the center of mass that falls down at with the gravitational pull. But like it literally doesn't, because that's still contracting. It's kind of like in an equilibrium, so that's why it's dormant. So that explains it a lot better. It really does. It does explain it a lot better, the gravitational.
Because like if you go back to thinking of the spring horizontally with the two people,
Yeah.
If
Exactly
if they were both to let go at the same instant, then the spring would contract inwards, wouldn't it?
Yeah, equally.
And meet at the center. Yeah.
So that's what kind of done it for me. That example of horizontal holding the pressure, and obviously if one person let go, if there is a force, then that would be consistent with, obviously there is still a pull on that spring, but you know, if you found like an equal, where say like they're both pulling and one person lets go and the person still goes backwards with the spring, would he take the spring with him? I mean, that's kind of like, that's the only kind of way I can analogously translate the way that I think that if gravity, it works with your explanation, it's consistent. It's not like an anomaly out of gravity, so it works with the gravity. But at the same time, I tend to think that this gravity is a constant force pulling, so it wouldn't stop pulling even though it's been let go at the other end. So realistically, the position of the person holding it on the other end, it would continue to contract as it still makes progress downwards. But you're saying that contraction happens in the middle, where the center of mass of the spring. But I still feel like, is it possible if it really gravity? I don't know. Like it does work that way, but could it work if the guy could take a step back still? Because the other person lets go and he holds on and still goes backwards.
I think this is the best
Then the
we've
bottom
seen.
of that thing was still.
Paul has said that it's a pseudo force. I mean, very few ballers concede that it's not a force. You know, because we keep repeating it's not a force, not a force. So I think that you've got him to say it's a pseudo force. So
That was when he was talking about general relativity, though, when the gravitational pull or something like that. But that's the business spring. But yeah, all right, it's been a good talk. Yeah, I'll definitely think about it more. I'll get more fucking. I appreciate the better. Now we've kind of found each other's kind of middle ground, and we've got a good, productive conversation. I prefer it that way. So yeah, thanks for the chat, Paul.
No worries.
Welcome back to the globe.
Welcome to Flat Earth, Paul.
No.
Welcome back to the globe, Brummy.
So
no, I'm always. I can hear what they say. I hear the arguments. I understand the arguments. You know, I do have a few questions about them, and like, you know, if you don't ask the question, you'd be a fool forever. I'd rather be a fool for 5 minutes. There is certain things I don't know. I'm not an expert in everything, and I've always said that. I'm consistent with the fact that I don't think one man can know every single thing. It's just, you know, you're going to be excelling in one area and lacking in the other. It's just you choose what you win and lose in life. You can't be a champion at everything. So, you know, there is a certain point where you do have to rely on other people's information, etc. But it also, some people may have more information, just terrible teaching skills, or some people just have really good teaching skills and terrible information. So it still is up in the air. There's still things to discover, and I just feel like, even as crazy as people sound when they say like, oh, flat Earth or relative density or whatever, you know, it doesn't mean that you should just completely just disregard everything they've got to say, because I've learned a lot from what they're saying. I've learned a lot more in the last few weeks hanging around with flat earthers than I have been in here for 3 years.
Just curious, did you open the folder with the relativity books in it?
I did have a look at all the books, and I'm not a book reader. I've read 3 books in my life.
Did it scare you?
I just thought, oh, this guy, look at him showing. Look at my book collection. Oh, my general. So you've obviously got a lot of knowledge on it. You've obviously read all this stuff. So that's brilliant. You know, you've actually, when I asked Kosho to explain general relativity yesterday, it was probably the biggest shit show you've ever seen, known to man. Like, look, I'll actually send you the link. It is the funniest thing. Actually, I'm gonna play it so you can hear it. Like, it was the shit show.
We get Jin muted now.
Oh, yeah, Jin. Jin's hard work, isn't he?
No.
Yeah, give me 1 second. Give me 1 second. Let me just play Kosho's explanation.
I've let Jin out of the box. Be warned, I've let Jin out of the box.
Yeah, I think, you've been talking long enough, I think. You've had your mouth. That's my turn.
It's coming from you.
Sorry.
Yeah, right, you know. And anyway, all that shit you spoke, like I said, how does that relate in our reality when I drop something on the floor? Or that warping of fucking space-time shit? That's not what we experience here on Earth.
Bang on the money, Jin. I was just about to say when Paul finished.
I don't even know why you accommodate them with that shit.
Well, I was just about to say when Paul finished, it doesn't mean it's all true, right, Paul? None of it. It's all theoretical.
All fucking shit. Yeah, that's what I hate about it. It's just crap.
No, but Jin, you see, Jin, I think like for the sake of conversation, like we could just force them right now to demonstrate, but then there would be no conversation. So I think because they've studied this stuff, they probably.
I don't want vomit though. I don't want to hear vomit or sewer. I don't want to hear that. That's shit.
You understand the major disconnect between you trying to say provide a model or provide a demonstration to others, but yet you all fail to provide a model or provide a demonstration.
Right, I gave you a video that's calling you guys out. Get a model, make one. The Earth Banjo, he made a model for you to look at. Now make your model with water.
Excuse you, you were asked multiple questions and you ceded that you didn't have answers.
What are you talking about? What questions did you ask that I didn't concede anything? What are you talking about?
Well, maybe if you would just have been quiet and actually listened to the questions, you would be able to answer them. But no, you did not.
You can't be asking a question whilst I'm talking. That's crap.
You're so close-minded, Jim. You're so close-minded, mate. You didn't listen to anything that Paul was explaining.
Together because you're fucking all retards acting like you're in an asylum here. Basically, this is an asylum here. Fucking full of idiots.
So that's your answer for validation to the model and the questions posed.
You out. I'm going to whip you again with this video until you provide a video of your model. Where is your model?
You know that was specifically part of the question was not of another model, but to address the actual inconsistencies within the flat Earth model.
What inconsistent? You're comparing it to what? That's where it broke down.
That wasn't my question.
Chemo, you can just stop because you know that was a specific stipulation. What was the specific stipulation?
No, it wasn't.
Not about any other model for comparison.
No,
it was about the problem of measurements not actually complying with what presented as the flat Earth model there by Jen.
I put that video in. The reason for me to pop that video. Listen, well, he's lying. I put that, listen to what I'm saying and listen to the words I'm telling you. The reason I offered you up that video was because it's challenging you to produce a model of yours that works. You're not listening, you're just totally ignoring. Okay? Get your model with water cascading on it whilst it's spinning and demonstrate how the ships circumnavigate the Earth on your model. That's what you've got to do. That's the claim.
And we have something called the Round the World Yacht Race that happens every 4 years.
Well, you're not going to scapegoat away to that, Jen. You answer the questions about the problems with the flat Earth model, or you cede.
What problems? What are the problems?
I'm not ceding anything because I'm not asking any questions. You're asking the questions. I'm not asking the questions.
Yes, you've been asked multiple questions. Then go ahead and answer them.
How does that transform?
The reason I offered up the video was so that you would have to provide us you're asking for a model, you were asking. You've got to make a model.
So I want to play
You've got to make a model. So we've given you the model now. We've given you the model and it's got a challenge. Can you see how bad you are? Can you see
listen to Kosho's explanation about special relativity. It's absolutely hilarious.
Things orbiting a celestial object, and also giving the gravity well.
Totally not fucking interested in that.
Why are you playing video over here rather than just posting it?
Yeah, look, put the moon on that graph.
Its position is going to be the XYZ direction. It's not going to change its position. It's not going to change in that direction.
You're not interested, alright? So I mute myself. So I mute it, yeah? You don't want to hear it? Do you not want to hear it, alright?
No, it's alright, mate. Just post the link.
I've posted the link. It's a definite worth watch, man. But yeah, Jin, fucking chill out a bit, bro. Like, just what you want to talk about exactly? Just be more precise.
Well,
just screaming down the mic.
He's not really. I mean, he's saying that he's got a model, and the challenge is to put a globe model in front of us. So because this guy Cowbows is comparing something. He's saying, well,
negative. That is incorrect, Chemo.
Yeah, but you're saying this model is wrong.
Negative.
How is this model wrong? What are you comparing it to?
Apology rejected.
You know that that's incorrect, Chemo.
What's
it is
wrong
not
with the
about a
model?
comparison to another model.
Okay,
it
so
is
what?
addressing solely the flat Earth model that was
What is
presented
wrong
by
with this
Jen.
model that we've got so far?
Observations.
What? So what do you mean? What did you see that is wrong with this model?
Multiple people, multiple organizations, multiple groups have made actual physical measurements that do not actually match what this model presented. You have an opportunity here to provide an additional explanation, and that additional explanation must not include any reference to any other model. Any of this trying to say, oh, this other model is wrong as validation. You address solely an explanation for this model of the flat Earth that actually will explain why these measurements do not actually match this model as it's presented.
So you're saying don't talk about your model, but talk about your model. Talk
No,
about
no,
the
no,
numbers
no. I never stated it was my model. That's straw manning.
But again, what is wrong with the model we've presented? Why is it wrong?
It was just covered. There are multiple different observations and measurements that do not actually match with this. So this is an opportunity for you to provide additional explanation to explain these measurements to actually try and make them match the model presented.
But you're saying there is another model that has other measurements.
No, no, no.
What are you saying?
Negative.
What are you saying?
There are actual physical measurements.
But someone else has got other measurements
that do
that
not
are
match
modeling.
what's been presented thus far for the flat Earth model. You have an opportunity now to provide additional explanation for why these measurements don't match the model presented thus far for clarification.
That's what I'm asking you. So I'm saying you're saying someone's been out there, done some measurements and put it together, and they say what you're saying, that it's not this flat Earth. I'm saying, can we look at that so we can compare it? That was the point. How do we know you're not just telling fibs and porkies? Where's your model? So we can compare your numbers, your measurements.
It's like you, Chemo.
Whoever's done these measurements, where are they? Who are they?
Various independent groups, various independent individuals, governments, they've matched their measurements. Things such as the coastlines not matching, things such as angles and observations of where the sun is in the sky from different locations on the earth not matching what should be simple flat plane geometry.
Okay, so fair enough. You take
things
all those.
such as
okay, fair
the
enough.
eclipses.
You take all
things
those
such
measurements.
As how the moon is observable during
Okay,
the
I heard
day.
you. I heard you. But you take all those measurements from around the world, you put them together, unite them, so we have a united nation. And have you seen the United Nation flag?
Yes,
you see
I
what it looks
have.
like? Okay, so what does it look like?
It looks very close to
I rest my
that
case.
picture
So
of that
that would be the
map
idea, right? Is to
there.
take the united measurements and see what we get, and the United Nations say it's a flat Earth. They have a flat map on the flat flag. Now what?
Well, that doesn't actually comply with measurements, for instance, the various coastlines of different locations upon the Earth.
What it does is we've collected all the data from around the world. The United Nations gathered it all together and put it on their flag. And we can see that the flag is a flat Earth.
Can you give me a citation that that's why they've taken the AE map as the core of the UN flag? That they went around the world and measured everything. Can you tell me who did that? Do you have any evidence for it?
So let me show you a picture of the United Nations.
We know what the flag looks like. I want you to support the claim you just made.
So you need to show me, cowbells, what you're comparing.
Why is he ignoring that question?
The flat Earth model. Here's the flat Earth model. Look, United Nations agree with what we say. United Nations come together and unite all the nations' information, and we can see that they agree with the flat Earth. Now, you say you have measurements. Where are they? You keep saying it, but you're not producing it.
You made a claim there, Chemo, and you've yet to actually back it up.
Hold
Are
on
you
there,
just going to
Drussy.
ignore
Hold
that
on,
and
Drussy.
Are you going
So
to
look,
ignore that claim and
Carl
concede?
Bowles, we were
Or are
doing
you
so
going to actually
well,
address it? I'm in
talking
the middle
about
of a
models
sentence,
and
Chemo.
whatnot.
Why are you over talking me again?
Because you've
Please
just
don't do that.
derailed what's been said. He said...
you made a claim. I asked you to back it up.
Yeah,
Are you
he
gonna
just
back it
said
up, or
that
are you
he's
gonna
got
concede the
measurements from
point?
all over the world, and I'm saying,
No,
where
no,
are
no.
they?
That's the strong man, and that's actually false. I never stated that I had them, that I made them.
Who's done them then? I said, where are they? United
I'm glad you
Nations...
asked that question, Chemo. I'll happily
I
back
already
up my
answered that
point.
question, and you know it, Chemo. So let's continue on
You
with
said
the point
some
that he's
institution-
making that you're trying to ignore.
It's all right.
Support your
All right, so
claim
tell me now, what's wrong
that
with
the
the flat Earth
United
model?
Nations has stated it's a flat Earth.
Yeah, Cowbells. I've already substantiated my burden of proof by providing the Australian Geoscience Information Network, which has a history and dialogue of some of the measurements and surveys that have been done across the regions in in Australia, as well as the history behind it. So I've met my burden of proof. Chemo, do you want to now do the same? Ribbit.
Correct, and I also will reiterate exactly what he just stated to Chemo. Maybe it coming from me, Chemo will pay attention to it.
I'm listening. You said you've got data, but you're not providing it. I provided you with a flat Earth map. I provide you with a flat Earth flag that unites all the
No,
nations.
you have not.
What more do you
Provide that
need?
as proof that they are stating it's a flat Earth.
I don't see what the problem is with the flat Earth model here that Jin has presented. You've just said that I know it's wrong because someone somewhere has done measurements to say it's wrong.
Not addressing the point yet again.
So can you explain why the model is wrong? You say
He's now asking a question rather than satisfying the burden of evidence that has been put upon him.
How about just because you say so doesn't make it so?
Diverting from the point.
Correct, Chemo, and that's why it's not me saying so. There's multiple other individuals and multiple other groups that have taken multiple other observations that do not actually match what is presented by Jin as the flat Earth model. So it's an opportunity for you to explain. If you do not explain why these observations do not, on face value, match this, provide some alternate explanation, then you cede. Do you understand that?
I think he's seating all over the place as he's talking to you, trying to get your
No, I mean, you're making very little sense. You're saying that we've got a model here, and you have a model, but you won't present it.
No, that is not what's said, and you know it. You cede. Thank you.
Hey, Bells, just so to point, it's obviously ignoring the evidence that I put in the chat on your behalf. If you want to go up to 2:21 p.m. And you go to not Chemo, but Chemo is a rent boy. Not Chemo, but Chemo is a rent boy. You'll see a link at 2:23 showing.
What's that name again?
Chemo is a rent boy, and you'll see there's some data there from the Australian Geoscience Network.
But what you'll find is that.
Thank you, I appreciate that.
Do you need me to say the name again just to make sure you got it?
What you'll find
yes,
here,
please.
Cowbells, is that
Chemo
our model is scientifically correct, whereas your globe is not for educational purposes. So can you show me a globe model that is for educational purposes? And how we can compare the scientifically accurate, correct model to your globe model that's not for educational purposes?
Please provide substantiation for your claim that you have a scientifically accurate model when it doesn't actually comply with, for instance, the information he just posted about the coastline measurements not matching, or how about the angles to various objects in the sky not matching, or any of the other questions that were previously presented to you as an opportunity for you to explain.
Well, we've just provided you with the model, and you've just said, nah, wrong, you've just hand-waved dismissed. You just said, nah.
Incorrect. I actually allowed you multiple opportunities to actually provide an explanation for why these observations don't match, and you ceded by not
match
providing
with
those.
what? Match with what? What's it supposed to match to?
Chemo, I genuinely recommend that you go and you seek help to actually help with your mental infarction, that you don't pay attention to what falls out of that hole in your head.
Well, I like to stick to the science, and we have a scientifically accurate map, which is correct, practically.
How do you actually assert that as being valid when it doesn't actually match the observations and measurements?
What observations and measurements? Read it and weep.
You've just been provided that multiple times.
Top of the map there, it says scientifically correct and practically. That's
You've
what
got a
you
map
use
that can't be
practically.
used to measure distances. That's a hell of a map.
You keep on saying this, people, but where are your measurements? Where are they? Who's got them? Who's doing them? We've got the science.
I did a link earlier up in the chat at 2:23, not under the name Chemo, but under the name Chemo is a rent boy.
Was that Chemo is a rent boy?
It is Chemo is a rent boy. Chemo, why are you ignoring the information that's been provided to you?
Yeah, I also just posted a bunch of measurements of the Earth as well. So
We make sure we're clear. That's under the name J-Ace, not under the name Chemo is a rent boy.
So you're saying that someone has determined the shape of the Earth there, Jace? Jace is not even
Negative. Quite to the contrary. We've actually established that these measurements don't actually comply with the model that is presented for the flat Earth. And you have been allowed multiple opportunities to provide an explanation, and you have ceded that you have none.
But you're saying someone's measured the rate of curvature. You're saying someone's established a horizontal plane of reference and measured how much elevation drop is from the horizontal plane.
Yes, I have.
Okay.
yeah, it's all in the stuff that I posted as well. It tells you exactly how to do it. I've done it before. Anyone can do it. Like it's not difficult. It's not up to us to do it for you, Chemo. Just because you want to keep your belief alive or your troll alive or whatever you're doing, and you don't want to do these things for yourself, it's not up to us, man. I've already done this. I know the Earth is a globe. That's all I need.
Yeah. Unfortunately, I can't actually present the results because they were classified at the time I took the measurements. But working with aircraft at known altitudes, I established straight line distances to them at fixed angles from the horizontal and compared them with the altitude that one would expect on a globe with a radius of 63, average radius of 63.71 kilometers, or on a flat plane. And at 250 kilometers, there is a 7,000 meter discrepancy of how high the aircraft has to be in order for it to be on that established line at an angle of half a degree above the horizontal. So
yeah, that's how it's supposed to be done, Alan. But what we're looking for is a repeatable, practical demonstration that somebody's done, so we can repeat in the real world that an horizontal plane has been referenced, and then we can show how much curvature the Earth is falling away and how much drop there should be on a ball. That's 39.59.
Go out and get yourself a software-defined radio.
Why is Dawn muted? Where's Dawn? Why is Dawn muted? What's the reason?
Go out.
Any reason for Dawn being muted?
Chemo, stop talking over me, you twat.
I'm just trying to.
It's very easy. Go out, get yourself an SDR radio. You can get them for about 10 quid. Set it up so that it is using software that allows you to receive the ADS-B broadcasts from all of the aircraft within your local area.
Ah, he's back. There you go, Dawn.
This Chemo, stop fucking ignoring me while I'm talking to you.
No, I'm listening.
Well, why are you talking to other fucking people then while I'm talking to you?
Only you talking, Alan. I can only hear you.
Well, I can hear you talking back to somebody else, so you're obviously not paying fucking attention, are you? So, get yourself a software-defined radio, get it set up with the software for receiving ADS-B broadcasts from aircraft, and check the distance and the altitude of all the aircraft you can see. I am pretty sure for aircraft that are 250 kilometers from you, you will not see an aircraft that is below about 9,000 meters, give or take, and that should be at just above ground level on a flat plane.
Did you take into account turbidity? Probably not. Suspended matter? Probably not. So look, the problem in that is what you need to be able to do.
You know, it doesn't fucking matter. We're talking about radio waves at around 1 gigahertz.
No. You need a device that shows whether the Earth is dropping, whether it's horizontal, or whether it's curving upwards.
Yes, and the radio broadcasts from the aircraft tell you the aircraft's pretty accurate, exact latitude and longitude and its altitude above the ground.
No, that's not how you survey, Alan.
So
we're doing land surveying, ground.
Chemo,
on the ground.
shut the fuck up and listen to me when I'm fucking talking to you.
I'm listening, bro.
Chemo, just you will see that all of the aircraft that you can get returns from, that you can hear, broadcasting their position and altitude, is you simply have no aircraft visible to you at 200 kilometers that are below 9 to 10,000 meters.
Obviously,
you should be able to see the aircraft all the way down to the ground.
Obviously,
now,
though,
enough,
Alan,
if you can't see an aircraft that is below 10,000 meters at 250 kilometers, that would exactly coincide with the difference to the horizon of a globe of a radius of 6370 kilometers.
No, you're incorrect, because the horizon's not physical, and the only obstruction you have, as I outlined to you earlier on, would be the suspended matter that's causing a blockage, which blocks the sun. Think about it, Alan.
Fucking matter?
Oh, you won't even let me finish now, Alan. Won't even let me finish now. So you've got the sun being blocked by this atmosphere, these thick blankets, these thick layers of water and suspended matter, and you think you're going to see an aircraft through all of this, Alan? Can't even see the sun.
Well, I'm not using visible light, am I? I'm using a much, much longer wavelength. I'm using a wavelength of around about, I'm using a frequency of about 1 gigahertz. C equals F lambda, so you can work out what the wavelength is, but it's considerably longer than light. Light, it's actually a bit longer than, it's about around a meter. The wavelength of light is in the hundreds of nanometers. You know, the center of visible light's about 550 nanometers. So yeah, I'm pretty sure my radio waves are going to penetrate whatever you want to call it.
No. Again, if it's blockage, it's not going to get through it there, Alan.
Does radio get blocked by this, Alan? At these frequencies?
If it doesn't see the other aircraft, then yeah.
How strange.
Sorry,
if the aircraft doesn't see the other aircraft, then it's blocked.
Yes, by something.
Not the curvature of the Earth. Because the horizon is not physical. So wherever you say that horizon is blocking something, we can know that it's measurably, geometrically not measurable.
Where do you have to aim your radar when you're trying to see an aircraft at 250 miles? Do you aim it up at an angle that's commensurate with the flat Earth, or is it an angle?
Well, actually,
downward?
I would just fire it out horizontally, but that means you get lots of ground returns in the local, in the local area. So what I would do is I would point it up with the base of the
it's measuring
with the base of the beam pointing up at 1/2 degree. When it points up at 1/2 degree, you get this, pretty much what I'm posting in the side chat. There you go. That's the result you get is that all your targets are above the red line on that graph.
What's this? Is this your radar line of sight? Yeah.
Yep. This is my radar line of sight.
The blue one, the light blue one.
The x-axis represents line of sight distance to the target.
Yeah.
The vertical axis represents distance above the ground.
Right.
Okay. The blue line is what you would get from my radar pointing up at 1/2 degree on a flat plane.
No,
the red
you've got to
line,
account for the atmosphere bending.
The red line is what you get if you do it on a curved surface that has on the outside of a curved surface that has a radius of 60. Well, actually, it's actually our local radius for Norfolk, which is 63643 kilometers. So that is exactly what you get, and I never saw a return that would be below that red line ever. At 250 kilometers, the difference is around 7,000 meters.
Problem is, though, Alan, we get to hand wave dismiss these types of explanations because there's nothing practical with it. Whereas when we provide you something
practical with it,
when we provide you something practical, you can't hand wave dismiss because it's there for you to see. Everyone can see it.
But the point is that I can set up my ADSB receiver, and if I set the aerial up at sea level, which is pretty much exactly what I've got where I am because my house is at sea level, I will only see stuff out essentially on a horizontal line. It won't follow the curve. So the line will be a little lower than the red line that I see from using an ADSB receiver to receive the broadcast signals from the aircraft that are used by air traffic control to control traffic for safety. So please don't go telling me that information is incorrect.
Is that practical?
Yeah, and Alan, like I say, you can
plot the location of the target or the aircraft. You know your own location. You know the location of the receiver. Therefore, you can calculate the distance to the aircraft, and so you can plot its distance from you and its altitude. If you do that, you will not find that you get aircraft that are significantly below the line that it says you can see. I mean, there is always some slight variation because the atmosphere can affect radio waves in a minor way, much less so than they affect light. Because
Alan, this is not very compelling at all.
Because refraction is wavelength dependent.
But Alan, we're looking for compelling ways to spark the mind. So we say, yeah, that's something I could show somebody else and teach. What you're saying, this can't be taught to anybody else. And nobody else can do it.
I've just told you, you can buy an SDR receiver along with the software, which is free and open source, by the way. You can get an SDR receiver with the software that will do this for you so that you can do this yourself.
Yeah, all programmed, all pre-programmed to give me the right answers to tell me we're on a spinning ball, right?
You program it yourself then.
Yeah, and it will show that the horizon is not physical, and it will show that we are not on a curved surface, and it will show that you can't fire it to the moon. Then what? You'll say we didn't do it right. That's why you need actual practical measurement from A to B. Otherwise, you're just guessing.
Chemo, this is what is used. In fact, because everybody's gone over to because pretty much everybody now has to have an ADS-B transmitter on their aircraft, even the smallest of private aircraft, they now use it for air traffic control, for controlling the aircraft, for aviation safety, for manned aviation safety.
Yeah, but all of your stuff works on a flat Earth anyway.
For controlling this stuff is that good. They use it for controlling aircraft, for controlling the thousands of aircraft that are traveling all around the globe, all of the time.
All right, let's just agree to disagree. Unless, I mean, we can carry it on, but I mean, maybe there's probably.
Well, you just go, radar. Nah, radar doesn't work.
Yeah, because we don't have a practical demonstration showing exactly how it works, what it does, and again, it's just like nobody can do this on any given occasion. That's the point.
You can go to any first year physics lab at any university. You might even find some schools that have the equipment to be able to demonstrate all of this.
If you can find one open in this crisis here, Alan. But look, the idea is that something like that should be able to be done without schools.
Unfortunately, a global viral pandemic is not something I have any fucking control over, is it?
No, but that's the point. We should be able to do this from home, from any, like people are working from home now. Now it's like we can't do science from home anymore.
Go get yourself an SDR then.
So are you saying the scientists now can't do science because if you do it from home, it's not science? Exactly, Alan. So that's the point.
I'm not. I'm just saying you need to have...
What? I'm saying that it should be able to be done at home anywhere, not just in a school, Alan. You're saying go to some school. I'm like, well, what school is even open at this time of day or, anyway. But the point is you should be able to do these science things anytime, anywhere, any place.
Chemo, now you're just being completely fucking disingenuous.
No, when it comes to gravity...
So you're saying that everybody should be able to have access to any sort of equipment they need at any time in any place?
No, science, because science... Stupid. Alan, because science is the natural and physical world, like nature, yeah, you can do this anytime, anywhere. Water is everywhere. Temperature is everywhere. Different kinds of temperature. These things are everywhere.
For God's sake, Chemo, you are a complete and utter fucking retard.
Well, again, if it's just a select people, a few people who have technology who could know things, then it's just man-made. It's not science.
Chemo, you never went to school even when it was open.
It's not about me. But what we're looking for various ways. Now, look. Shows all over the place, discussions all over the place on this very question. But attacking me, Alan, is not going to solve the mystery of what the shape of the Earth is. Now, we know
we pretty much know what the shape of the Earth is. We fucking measured it, arsewipe.
That's what we're trying to find out, Alan. Who's been measuring it? When did they measure it? Can we actually repeat that measurement?
Fucking thousands of fucking people have measured it, you fucking
That's
idiot.
what we've been told. That's what we're trying to find out.
Hey, relax. That's
That's what we're trying to find out. We're trying to find out.
So I come on here because if Chemo's here and I'm talking, I'm going to get fucking angry with Chemo and call him out because he's a fucking retard, because it makes me feel fucking better in this lockdown.
Well, what we're looking for,
it doesn't make me feel
is
better.
simply a
It
person.
infringes on my rights to have a pleasant morning and not listen to someone screaming fucking retard at the top of their lungs. You know what I mean?
What we're looking for.
Retard, fucking retard. Chemo is a fucking retard.
Don't worry about it. I mean, we're having fun at the end of the day. And
just take a quick break. Calm down.
For me, at the end of the day, we're having a bit of fun.
Don't
And look, at the end of the day,
Chemo exactly what he wants.
No, that wasn't down to me. I mean, look, this happens, okay? People think that we're being
bad behaviour.
That was so unnecessary, I would have said. People should be allowed to express. People should be allowed to give their opinion. If they feel someone is not being honest, who are we to stand in that? So, Alan, that was a bad move. I would have let you, say what you got to say, because you're not going to say it forever, are you? You would have said it, we would have moved on, and we would have still been talking about radars. But now you've got me monologuing for some reason until the room complains that I'm monologuing too long. And,
You're such a crank, Chemo, double time. You just blamed him for you monologuing?
Yeah,
you
but
can stop
why'd you
monologuing right
do
now,
that?
man.
You shouldn't let that happen. I mean, again, this is why it should be an open platform for all to give their opinion. That's the beauty of Gem's server, right? Because people get to say what they really feel about the situation that they're in. And yeah, if we're wrong, like the flat earthers,
I'll actually contribute here.
That was the
Hey,
craziest.
go on then.
Hey, Chemo, I'll let you be aware of this.
Can we get Alan back there? Because very unfair. I feel uncomfortable off the back of me.
Another minute or so, and I'll unmute him. Just give him.
Well, I'm gonna. If he's silent, then
I just started a timer, so I'm gonna let the timer finish.
It's unfair. Dawn was mute. I mean, it's just unfair. Well, he's gone now.
So,
anyway,
Chemo,
so let's continue.
I started. Okay, he's gone. So if he comes back, I think we can unmute him when the time's up.
So yeah. So cowbells. What's the issue? Shape of the earth.
Hey, Chemo, I'll let you be aware of this now. I've been observing you for the better part of a year, and I've actually been conducting an experiment, your behavior, over a month now.
Sure. Okay.
And I get the possibility that you actually have some mental infarction or impairment, and do not actually register between your what's called short-term memory and long-term memory, as you don't seem to actually cognitively understand the things that you say.
Right.
Because you ask questions about when you're asked about something you just stated.
Yeah. I mean, that's one possibility. But I always say there's only one way to find out. That would be to practically demonstrate that the Earth is a globe. I mean, otherwise it looks like that we are on the right path. And, it's a path of truth. It's a path of honesty. And what we're showing is the people supporting the globe, they simply cannot defend it in the right way, which is with the practical demonstrations. So you're going to resort to what you know, which is attack the messenger. That's always been the case for many, many years. I mean, Julius Caesar's must
Let me
have...
clarify. This is actually a genuine concern and recommendation that you go and you find somebody else to observe you as well.
Yeah.
Because don't take my word for it. Don't take my observation. Have some sort of validation. Because if you don't actually do this, you're going to have problems later in life.
No, I believe you. And like I said, there's only one way to find out. And that is obviously to present proof, not evidence of what you think is happening or hypothesizing, or even using pseudoscience. But yeah, if we've got it wrong, then you could consider what we're doing as more than mental. Like, we would be a threat to mankind society for disrupting known education. This would be a huge problem, yeah, for sure. But at the moment, right now, presently, currently, in real time, none of you can provide anything practical that would satisfy anyone that we're on a board. Like, the people that support you, cowbells, they have when I say agenda, what I mean, I don't mean an agenda as in, like, the New World Order. I just mean that they want this society. So you like the idea of technology advancements, you know, being a leader of something. So why would you want to give that up by going back to an idea that was supposed to be ancient, right?
That's actually incorrect. There's actually numerous people who have aversion to new forms of technology. And so there is that consideration to account for. It's not just, oh, we all like all this new stuff.
So, I mean, look, it's like this. So 500 years ago, the idea was to eliminate this religious idea, like what you're doing right now. So it's like a reset. So it's like we've come full circle, and now we're trying to eliminate anyone's religious idea when it comes to the shape of the earth. So what you're saying is part of that religious idea. You're saying, well, we've got it, we've done it, someone's done it, all this kind of wonderful stuff, but you're not actually presenting it. So that's what we're starting again. We're saying if you've got proof or evidence of a claim, present it. Otherwise, it goes into the religious category, and then obviously you can't go forward with that idea because you can't demonstrate it.
Whose question was it, Kimo, who said you might have weird memory?
This is Cowboys.
Oh, so what's his theory, that because you keep coming back doing a similar thing, you forgot you did before?
Yeah, so like a goldfish, memory like a goldfish, something like this, I think he's saying. But I mean, I
That
get it. I
goes
mean,
for all people, right? It goes for everyone that keeps doing the same thing.
Yeah, he's
Why
caught
do
in
you
this. Yeah, well, obviously he's caught in the same cycle, not aware of it. But
Yeah,
and that's why I
there you go.
say, you know, there's only one way to find out, right? But time will tell. And it's not going to be now, is it? It's not going to be the now time. So we're safe for the moment, I would have said. No one's going to put us in white jackets just yet. But if it turns out it's a ball, it's me. And we keep saying it's flat.
Can I just go over that again? Cabals, I think you should maybe talk to someone else about, see if you've got an issue with your memory, because you keep coming back and doing the same thing. So I was just worrying a little bit. Yeah, second
That's
opinion.
not-
Thanks.
Do you have actually measurements of that? Because there's multiple measurements of chemo.
Measurements. Yeah, I saw you here
stating
yesterday
something,
and the day before, and the
immediately
day
being
before that,
asked
and the
it,
day before that.
and then
That's my measurement of you doing it again and again and again.
Time was his independent
Then
variable.
he
So
actually
just get a second opinion. It's fine, mate.
indicated
Just go to the
he
doctors, get a
has
second
no
opinion, and then we can
idea
all move on.
of what he just stated. Is that clear? Are you
Get a
saying
second opinion. Get a second opinion.
did you have measurements of that of others?
Yes, I've got measurements of you coming back doing the same thing over and over again. You might have an issue with your memory.
I thank you for your concern, and I will try and validate that.
Cool. It's good to help each other, because if we have issues, then we can point them out for each other.
The only problem is some people won't listen.
That is a problem, yeah.
Sure is.
Good idea. Let's start with you, Dawn. Now, does anyone have any of Dawn's issues that they'd like to talk about?
Sorry, what happened? What's the question?
We're going to go through everyone's issues, but we're starting with Dawn since it was his idea.
Mental health day.
Ah,
yeah.
Oh, we're starting with Cabals because it was his idea, Jim.
Okay,
Maybe you
then
missed that.
Candle, what Chemo just stated